Hello everyone, this is Ashirwad and welcome to .NET Conf Bhubaneswar. And glad you people registered and let's start the keynote. So what is .NET Conf Bhubaneswar? So .NET Conf Bhubaneswar is a local developer community event organized in partnership with .NET Foundation to spread the word about the .NET 5.0 release. In this particular event, we are going to discuss all about .NET, starting from microservices to Blazor. So before we dive into more details, let's look at our agenda for today. So these are the sessions that are planned for the day. So first we'll start with building cross-platform mobile application using Xamarin that is going to be given by Teams. Then we have a session from Nish on microservices in .NET. Then we'll have a session on building browser-based apps with Blazor that will be given by me. Then we are going to have another session on serverless architecture with .NET 5.0, achieve a scalable and secure solution by Gabriel. Then we have one session on building broken messaging for .NET Core applications using Kafka that is going to be given by Abhishek. And then we have the last session for even there's clean architecture and using Mediator and web APIs for CQRS pattern given by Sanjay. So before starting off the event, I would like to introduce our community. Utkal Tikis Forum is a community which is actually hosting this event and organizing all of this. So let's go through some of the things that we have done in the past. These were some of the events that we have previously done. We have been doing a lot of community events of late, and since the lockdown started, we have gone completely virtual, and we have done a few of our virtual events. And this was the last event that we did way back on 12 December. So we thank our sponsors. .NET Foundation is a streaming partner. It helped us with the streaming platform. And then we have Microsoft, who is sponsoring us with some exam vouchers. And we have Pact, who is generous enough to give us some ebooks to our speakers, as well as our attendees. So good news for all the attendees who has registered in Eventbrite. They are going to get a coupon from Pact, which they can use to buy any of these 4 books to get 25% discount. You can go to Pact's official site and get your copy there. It is you can avail 25% discount on the e-copies as well as the paperbacks. Now, okay, ebooks for selected attendees from Pact. During the session, the person who asked the best question, the question will be selected obviously by the speaker, whose question is selected by the speaker that this was the most interesting one, or this is something which they found was quite what we say quite good. Then that particular person is going to get this e-copy from our sponsor Pact. And finally, you're going to get free exam vouchers from Microsoft. But to get that, you need to give a quiz, and the link is already there in the mail that in the reminder mail that you got from Eventbrite. So in there is a quiz link which you can use, to give the whole quiz, and the top 5 scorers will get free exam vouchers, which are valid for all role-based exams as well as the 70, 74, and MB series exams. But you can't use it for AC900. So let's get started with the event, and I'll just stop my screen and ask James to join in and start off his session.
Awesome. Thank you so much for having me. I'm super excited to be here, and I know we got a lot of people joining in, and it's really cool to see not only the amazing communities around the world, but kind of all the really cool thing that Packet's doing, giving away as well. So thank you for having me. Thanks for inviting me. And I'm super excited about the awesome sessions. I know Nish is after me. I've worked with Nish for, I don't know, has it been like 7 or 8 years? I see Nish's little face down there. You can't see him, but like, check this out. I bring him in. Oh, there he is. Say hi, Nish. Oh my goodness.
Hey,
then he's gone again. Then he's back. I'm super excited. I like that I have control of all this too. It's my new favorite thing. All right, well, I'll get into it. Here we go. All right, so let me go ahead and share my screen really quick over here. I'm going to bring this up and screen 1 and boom, perfect. Awesome. Well, I'm again super excited to be here. I'm James Montemagno. I am a PM lead over at Microsoft, and my focus is growing and engaging and helping the .NET community be successful with the awesome team that I work with every single day. I've been a long time Xamarin developer in the community for almost 10 years. I worked at Xamarin, then came along at Microsoft after the acquisition. and sort of moved into this role of going beyond .NET, because I think what's cool about .NET is that it's all sorts of different, operating systems, platforms that we can target, all with C#, F#, VB, leveraging .NET runtime across all of these great operating systems. So to me, it's really nice to expand this role, but my heart has always been with mobile. I can't help myself. Even over the holiday break, I developed even more applications that I put out because I love the technology, and I love that I learned C# nearly 15 years ago, and I can take, actually beyond 15 years ago now, but take all that knowledge and apply it to all these latest operating systems that are out there. So today what I'm going to do is I'm going to talk about and demo sort of what's new and next for Xamarin developers. But also, if you're brand new to the world of C# and .NET, show you what Xamarin is, how you can build mobile applications for iOS, Android, and Windows with C# and .NET, and also what we're going to be doing this year going into the fall with .NET 6. I'll monitor the chat and comments over here too. So if you have any questions at any time, just feel to pop in a question into YouTube. So let's get into it. So with Xamarin being part of .NET, the goal is really to delight developers and to enable developers to build applications for these modern operating systems, whether it's Mac, Windows, iOS, Android, or target other operating systems that .NET can run on, like Tizen or Linux or anything else. The whole goal is that Xamarin brings in that mobile component for iOS and Android and builds a layer of compatibility with .NET, which means that you can run and write C# and .NET code directly on iOS and Android devices and share code with all of your .NET applications. And this is something that's really cool because if you're building web applications today with ASP.NET or Blazor, you can share a lot of your logic with your mobile apps. Or if you're building desktop apps for Windows with WPF or UWP, you can share a lot of your application logic with iOS and Android with Xamarin. But with Xamarin, it goes beyond just sharing code because there's really important frameworks that the Xamarin team delivers to make developers more productive and be more cross-platform. And the first one here on the list is Xamarin Essentials that I'll talk about a bit later, which what it does is it enables developers to get access to cross-platform native features. The cool part about Xamarin is that you have access to iOS and Android APIs in C#, but Xamarin Essentials abstracts them into a common API. So things like connectivity, taking a photo, geolocation, email, SMS, you have access to those from a single shared library, all just available to you right away. And then Xamarin Forms is our cross-platform native UI user interface layer. And you're able to write your entire UI layer in XAML, which is an XML-based markup, or C# or F#, and create cross-platform native UIs across iOS, Android, and Windows. So it's really nice from a developer point of view that you get access to all of these APIs, and then you're able to share a bulk of your business logic and still create highly performant native applications. We'll take a look at that today. Now, what's really cool, again, is that since Xamarin is just part of .NET, is that you get access to all of the amazing ecosystem of .NET. So things like Azure Active Directory, Prism, Poly, great, amazing component vendors like Syncfusion and DevExpress and Telerik and Raygun and Cognitive Services from Azure and all the Azure SDKs and AWS SDKs, anything you want, are available because they're running C# and .NET. And there's an amazing C# and .NET community. A lot of you are here right now watching the stream and putting this on. But what's really cool is that there's amazing developers building these libraries that we can bring directly into our apps. Well, the team focused really hard in the most recent releases of Xamarin and Visual Studio to enable developers to get started faster, the team actually reduced the install of Xamarin by 2/3. So it used to be about 23 gigs. It's now only 6 gigs. And that includes everything you need to get started, including SDKs, the Visual Studio tooling, emulators, all the base that you need to just get started, templates, everything like that. And it's still quite a lot because 6 gigs seems like a lot, but it's because with mobile development, there is a lot of other additional things from Google and Apple that are installed and required to build, since it's not Windows, it's not a Mac, they're additional APIs. But this means you can get started really fast, and it's twice as fast to install. And that productivity that the team has been focused on is not only just getting started faster, but also to be more productive. And that's kind of where I want to start the talk today, because there's a lot of work that has gone into Xamarin and Visual Studio in the last year, and beyond, many, many years, and continuously. So when the team thinks about what developers need beyond sharing code, is that they need to be more productive. So the team has integrated in IntelliCode into both C# and XAML editors to help you code faster. IntelliCode basically finishes what you're typing and gives you smart recommendations based on AI. You can deploy to multiple platforms at the same time. You can even debug third-party packages from NuGet and GitHub via source link directly in Visual Studio and Visual Studio for Mac, which is very helpful. The team has also shrunk down the build and deploy times, some of them up to 50% faster, and also integrating in new technology from Google, such as APT2 and incremental APK builds. And all that means is that your Android apps build faster and deploy faster, which is super important. And then also there's a lot of new technology from Google and the .NET team enabling your applications to be smaller and start faster. So there's something in Android for Xamarin now called startup tracing, which is a ahead of time compilation technology that can reduce your startup time by 60%. And additionally, integrate into the Android ecosystem of bundling your applications with Android app bundles. And that's a really cool technology that can reduce your Android app size by up to 50% when you deliver it to Google Play. And finally, the team is always focused on helping you iterate faster while you're working and creating your user interface. So a few key pieces of technology is XAML hot reload, which I'll kind of show here today, which enables you to make changes to your UI and see it update in real time. And additionally, there's another cool piece of technology that is called hot restart for iOS. And this is a really cool piece of functionality that helps you deploy and recompile your iOS application directly to an iOS device from a Windows machine without the need for a Mac at all. It kind of deploys your app inside of an app, which is nice. So let me go ahead and show you exactly what this sort of new Xamarin experience looks like from Visual Studio. So I'm going to go ahead and just show you like what it looks like to get started building an app with Xamarin and some of the things the team has done there. So normally what you'll do is come in and say, create a new project. And then you'll have all of these templates. And what I've done here is I've simply gone in and said, give me all my mobile applications. And we see things like Android Wear applications, watch applications, iOS, Android applications. Then we see this one here, which is mobile app with Xamarin Forms. And this is our cross-platform template that you can go ahead and start building iOS, Android, and Windows apps from that shared code base. So we're going to tap on that and we'll call it app 4. That sounds good. And this is our new templating system, so you can preview what your application will look like ahead of time. So you can go in and you can say, oh, I want my application to have a flyout menu. We can see it kind of navigate out here, have tabs on the bottom, or just a blank app. And you can decide if you want iOS, Android, or Windows here, and you can decide what operating systems you want. So I'm going to go ahead and just save a few seconds. I created a project ahead of time. It's called app 3. So I was creating app 4. Now I'm creating app 3 is where I'm at. And this is what the solution looks like over here. You have 4 projects. First is a .NET Standard project. And this is where all of my shared code is going to go. So right now it's just this main page, which has something that just says, welcome to Xamarin Forms. And then I can add any of my models, my Azure integration, SQL databases, any more of my custom pages that I want. Everything can be shared in this .NET Standard library. And that is being shared with my Android, iOS, and my Windows UWP project here. And what's cool about that is that I can customize any of my settings, versions, splash screens, icons for those applications there. And they have very special, compiler settings and customizations that you can do. So all I did is just created the project, and I'm just going to go ahead and hit debug and deploy it right on my machine here. So I'm going to go ahead and let it boot up. There we go. And let me try one more time here. There we go. All right. There we go. Cool. So I'm going to go ahead and just pin these over here. There we go. And now I'm kind of inside of my, setup here on my machine. We have my application running on the right. It says, welcome to Xamarin Forms. On the left-hand side, I have my visual tree. This is really cool. This is a live visual representation of my application. I can tap on one of these labels here, and it will show me exactly where it's at in the source code. So I can go ahead and do that, which is nice. So as my XAML gets bigger and more complex, I can sort of navigate around to it. And then what we can see is that I have this frame with a background color of this blue. It says, welcome to Xamarin Forms. And we can note that hot reload is enabled right here for my Windows application. So that means if I want to come in and change the background color to, let's say, orange, it updates in real time with XAML hot reload. I actually don't even need to save my file at all. It just handles it for me automatically. And I can do everything. And I can say, follow me on Twitter at James Montemagno, and then it'll update as it goes, right? And this is our brand new changes, applied changes, hot reload. So it's kind of a hot reload version 2.0. So instead of reloading the entire page, it's sort of doing a diff in the virtual DOM, if you will, here. And I can show you what that means, because what I'll do is I'll put an entry here, and that entry will show up over here. So we can see it over here, and I'll say, hello, everyone, right there. Just kind of type it. Then if I was to change this to something like pink, we can see that actually it's still there. Hello, everyone. So it is only changing whatever you are actively changing in that element. So when I change pink, or I change to, let's say, deep pink, and now it changes to deep pink here, everything on the page remains the same. So all of your state is retained, which is really cool. But there's a lot of other cool features that are built in. So for example, I have, I did add 2 lines of code into the code behind here in the main page code behind. And I created a little string that says, is named hello. And it says hello from the code behind. And that's my binding context here. And a cool feature that was added into the most recent releases of Visual Studio is this XAML binding failures. So here I can do a data binding. So let me go ahead and add a binding here. And I'll say hello, for example. And you can see that I typoed it because it says hello with 1 L. But we'll see down the bottom that hello, the property, which is not spelled correctly, is not valid. Additionally, we'll see it right here on the hot reload page, which is really, really cool. And also over here on the live visual tree. So there's many places to alert you that something has gone wrong, right? Which is really cool. So once I fix that over here, there we go. I can go ahead and clear that out. And now my data binding works and it's perfect. It's good to go. And what's nice about this entire experience is that now, if I want to, I can go ahead and set Android as my startup project and go ahead and hit deploy. And all of the changes I just made will be applied to Android now. So I just said start it up on my Android emulator, and I don't even have it running yet. So it's going to go through a compilation here, take my changes, and it's going to boot up our Android emulator straight from Google. And this is running on Hyper-V, which the team worked directly with the Google team and the Hyper-V team to optimize the Google emulators for Windows, which is really cool. So we can see we have the application here, right here. We have our live visual tree over on the left-hand side over here. Okay. Same thing. If I was to change this back to pink, you can see that it updates in real time here. Maybe we'll change it back to orange again. Okay. There we go. And then what we can do is we can also get that same exact XAML binding failure. So here I mistypoed hello, and we see it down here as well on the bottom. And also we see it in the top left in the live visual tree. Now there is no kind of adornment or a little like drop down overlay like we saw in Windows. So that's why you have it in multiple places. So you can kind of see it there that's going on, which is really nice. So let me go ahead and fix this. We see the data binding come back up. It says hello from the code behind. And I get that same exact experience, the live visual tree, the hot reloading, the XAML binding failures. Now, the last part here is actually to combine a few different pieces of technology to deploy this onto iOS. So I have my iPhone right here. This is an iPhone 7, I think, 7S Max, something, I don't know. So I have it here. It's 1 a.m. in the morning, as you can see, it's true. What I'm going to do is I'm going to go ahead and just plug it in to my Windows machine. So just go ahead and plug this in here. I'm going to unlock it and then plug it in. There we go. Okay. And then what I'm going to do is I'm going to set my iOS project as the startup. And what we're going to do up top here is instead of saying I want to go to an iPhone simulator, which would require me to go to a Mac, I just plugged in an iPhone into my Windows machine. And here we can see that I have the iPhone, which is the name of my iPhone, plugged directly in, and I can deploy to it using hot restart for iOS. It enables me to take my application and deploy it directly to an iOS device that's plugged into my Windows machine. So I'm going to hit debug here, and I'm debugging my application. I can set breakpoints, anything like that. And I'm just going to go ahead and do a screen mirror here, so you can see my iOS device on the screen. So let me go ahead and get that up here. There we go. Let's go ahead and put this over here. And what we'll see is that over in the output, it's actually creating my application. It's connecting and then deploying the application directly to my iOS device. And only thing I've done is I've logged in to Visual Studio with my Apple developer account. So I did do that, and that was it. And now I have my iOS application right here. Of course, I'm screen mirroring it here, as we can see. But I have the live visual tree, so I can navigate around to the code that I have here. I could change this back to deep pink, which is one of my favorites. And we see it update, and this is running on my device. So if I hold it up here, you can see it right here on my device, and it's being stream mirrored. So there's no Mac in between. It's directly just to my iPhone, and any iPhone would work, or iPad, or anything that you have. And you can start optimizing and using Visual Studio from Windows here. Now, of course, if you have a Mac, well, you can just go ahead and install Visual Studio for Mac. You get very similar experience, but you can just deploy directly to an iPhone simulator or plug in your device into your Mac, and you're good to go. But this is an amazing experience that makes you super duper productive, because you're not only leveraging the same exact XAML across Windows, iOS, and Android, but you're using these great productivity tools. We're the only ones out there that enable you to get this type of productivity and deploy to these devices all from one single machine, which is honestly really spectacular. I think is just absolutely phenomenal. So let me go ahead and go and a little bit more. Let me make sure this is not always on top. There we go. Perfect. Cool. All right. So I told you a little bit about hot restart. That was enabling me to deploy to my iOS device directly from Windows. And what's great about this is that it is really optimized to enable you to have really fast build and deploy times. So we can see here in our comparison chart between with hot restart and without hot restart on a very large application, we're shrinking down the build times from nearly 3 minutes to 20 seconds. The initial deploy, it's a larger package, so it takes a little bit longer to do the initial deploy, but then incremental deploys and builds are much, much faster. Look, 40 seconds down to 3 seconds. And then to deploy, it's even faster because then the diff that we deploy from Visual Studio is much smaller. So 14 seconds down to 7 seconds, which is great. So, really squeezing that productivity. Now, the rest of what I want to talk about today is what the team is doing and the community is doing across Xamarin Forms, the Xamarin Community Toolkit, and Xamarin Essentials, which are all really essential parts of being a cross-platform mobile developer with Xamarin. Now, in 2020 alone, in Xamarin Forms, all of these features were shipped either in preview or into stable from the community and from the team. Things such as carousel view, checkbox, drag and drop, expander, GIF animations, multi-bindings, radio buttons. These are just some of them. There's hundreds of enhancements that have gone into it. Now, what's great is that many of these features were shipped not only in stable releases, but some of these more complex and controls were shipped into preview. And many of them came out of preview, such as the indicator view and carousel view. But what the team wanted to do is really focus in on getting any of these experimental features into a stable release. And just this week, Xamarin Forms 5.0 release. I guess it wasn't actually today. That's when I made this slide deck, but it was Wednesday. So just this week, Xamarin Forms 5.0 release, which is the largest release of Xamarin Forms yet. And I'm really excited about it because it took all of these features and brought them into stable. And I want to talk about them and demo them off. So things such as brushes come to every single control inside of Xamarin Forms. So things like brushes to create linear gradient brushes, radial gradient brushes. You can apply them to anything, backgrounds and navigation backgrounds, anything at all, and create these really beautiful views. And it just applies to everything. I use them on everything already. Carousel view, that's another control that was in preview for a while and enables you to flip left and right through different items. And then you can also use the indicator view to put those little dots on there. Drag and drop, which is great, not only for like dual screen devices such as the Surface Duo, which Xamarin Forms has first class support for, but just for enhancing your list views and collection views or creating interactive elements on your application. And you can apply it to anything. So you can apply it to buttons, and you can have different events such as drag started, dragged over, drag leave, and it will do the smart thing and create sort of the shadow image and these plus icons. And you can even drag things outside of your application. So if you were dragging an image to another application, you can do that as well. So like into an email, and it handles it automatically for you. Now, radio button is a small one, but it is one that doesn't exist necessarily on all platforms like iOS. So the team uses native drawing APIs to draw radio buttons on iOS. But of course, it's available for iOS, Android, and Windows and Mac. But radio button also has something very special, which you see on the bottom here, which is a control template. And so on the top part, we just have 3 radio buttons of day, week, month, and we get day, week, month as radio buttons. On the bottom here, we're telling the templating system what each radio button should be like. So for example, we're telling it that there should be an image and a label, and that is the control template to use. And this is the first start of making every single control in Xamarin Forms templatable. And that'll be a theme as we kind of go forward into future releases. So it's really, really cool. So you can really customize the control and aren't stuck to just here's the normal radio button. And I just said that Xamarin Forms for radio buttons on iOS uses a native drawing API. And in fact, there is now a native drawing cross-platform API for every single developer using native drawing APIs for iOS, Android, and Windows, and it's our Shapes and Paths API. So this enables you to do things such as draw lines, do paths, do polys, do ellipses. And here what we're seeing is lines with dashes and dots on them, and paths that you can even put SVG data into. You can draw SVGs with these shapes and paths too. There's even clipping APIs, so you can clip any control. So if you wanted to make a circle image, you can also do that too, and I'll show you that in the future. I think I have that in my next demo. Yeah. Swipe view is a really cool one. It's one that sort of complements a collection view or a list view. But the swipe view can be applied to anything. So you can swipe left, you can swipe right, you can swipe up, you can swipe down. So you can create those interactable features. And these are just all built right into the box of Xamarin Forms. Now, those are just some of the features of Xamarin Forms 5, but I would be, it would sadden me if I didn't tell you about this other initiative that the community is building with the Xamarin team called the Xamarin Community Toolkit. And the goal of the Xamarin Community Toolkit is that they want to build out basically all of the important pieces of functionality and controls that aren't in the main toolkit of Xamarin Forms. So I talked about these experimental features, and many of them now are just stable. There were a few, though, that got moved into the Community Toolkit, such as C# UI extensions, media element to play back movies and things like that, and then the expander. But the Xamarin Community Toolkit, which just released into version 1.0 this week, has a lot more. So it has built-in behaviors, extension methods, object models like async command and observable range collection, different views such as a camera view, a side menu view, an avatar view, and tons of converters built right in. So you can go from file new and then pull in all of these amazing helpers into your Xamarin applications. So here's a very short video that I'll walk through really quick here. So here is just me, is it plan? There we go, going through, there we go. So this is the sample application in the Xamarin Community Toolkit repo. So here are some animations that you can play with a single line of code that animate things in and out. There's masked behaviors on different entries that you can automatically add. And then, of course, there's tons of views, such as an avatar view, so you can have letters or images, a range slider, so kind of two up and down and change colors of it, and thumb sizes and things like that. There's also the side menu, so you can swipe things in and out from the left and right. And then also a camera view, so you can actually bring up a camera directly into the view and start a recording, which is really neat. And there's a lot more too, such as expander, which has these nested really cool views. You can expand things up and down, and there's more being added all the time. So if you've ever worked on a control and have something really cool that you want to add, you can add your control to the Xamarin Community Toolkit. So what I wanted to do is just kind of show you an application that actually David Ortnow, one of the PMs on the Xamarin Forms team, the lead PM on the Xamarin team, built for the most recent .NET Conf. And I think it's a really good example of some of the cool things that you can do with Xamarin Forms. So it's an application that's called Los Gatos, which just means the cats in Spanish. And the whole idea of these sort of, he found these really cool images of the sort of these hipster cats, and he wanted to create an application that's sort of like buying stickers, basically, and artwork and T-shirts for them. So it's a really beautiful application, which enables you to kind of swipe left and right with the collection view. We can kind of swipe through here in the application. It also has these tab bars on the bottom down over here. And you can see as I tap on one on my iOS device, it actually does like a little animation. That's using a tab view, which is part of the Xamarin Community Toolkit. It also has light theme and dark theme support, which is built directly into Xamarin Forms. There's a new API for that. So you can see here that that's directly built right in. So I can toggle this on and off, and it would also adhere to the operating system, but I can toggle it on and off automatically here. It also has some really cool things, like I can drag and drop this image just by holding it down over here, adding it into my cart. I can also tap on one of the images, get transitions that come in. So we can see here all the different colors and things that are available here. I can also then go back and into the shopping cart, and we can see I've added some things here. So I have the swipe view. So I'm swiping left, swiping right. I can remove it. I can add it here. I can increment the count up and down. So I get this really beautiful card-based UI inside of here. And also a few other things. So there's these kind of card views. There's David there. But we also have, this is a radio button that you see here that is actually represented here on the screen is just a nice little radio button using those control templates, which are really, really cool. So you can create these really beautiful dynamic applications with drag and drop, with carousel views, collection views, swipe views in and out, and craft these really beautiful applications and make sure that it's themed correct across light theme, dark theme, your application. And this is an application that you put together in about a day or so, just as a nice little sample, just to kind of show off what an application he could build really quick with all of the brand new Xamarin Forms controls in Xamarin Forms 5. Now, the last part, though, that is not UI based is all of the other stuff that you want to do when you're building mobile apps, which is access those native APIs. And I talked about earlier that Xamarin Essentials is our cross-platform native API NuGet package that enables you to do that. Since with Xamarin and .NET, you have access to all of those APIs in C#, Xamarin Essentials abstracts those for you. There's over 60 or 70 APIs available, and it supports every single major platform that the Xamarin platform supports and beyond. So iOS, Android, Windows, which we've seen a lot today, but it also supports watchOS, tvOS, and Tizen via the Samsung team. Tizen is an operating system from Samsung that works on phones and televisions and watches. But it also now supports Mac OS. So you can actually access these APIs that you just saw across all of these different operating systems, whether you're building your UI with Xamarin Forms or with the native toolkits. The team just released Xamarin Essentials 1.6, which had our most contributions from the community yet, and added some of these amazing features that I'll highlight here in a video that of the demo app I put together. So app actions, that's a really quick one. Actually, I'll just rewind it here. It's a quick one because it enables you to long press on the home screen and then deep link into content, and that's a cross-platform API. You can now go in and have a cross-platform file picker to pick things such as files like images or PDFs. You can specify only images or only videos, pick multiple files that are returned from disk. Media picker is similar, except for it enables you to not only pick an image, but also capture an image with the camera or a video as well, which is really cool and brings that directly in. Screenshots are great for support in your application. With one line of code, you can take a screenshot, and then with one more line of code, you can send an email and attach that. You can also use the Contact API, which is brand new, that enables you to pick contacts with a single line of code. and get back information, which I think is absolutely delightful. And everything is completely open source. You can go to aka.ms/Xamarin Essentials to learn more. I think these are really important pieces: being productive in Visual Studio, creating beautiful user interfaces, but also getting access to those native APIs. Now, one of the things that I've been talking about heavily is that with Xamarin, you can build these fast, beautiful native applications in less time with less code and leverage this amazing ecosystem that's been growing over the last decade and beyond. Now, with .NET itself, and one of the big announcements with .NET Conf last year in November was .NET 5. And with that, the goal of .NET has always been to enable you to build for anything. Today, we already saw that I was building for Windows and iOS and Android. And of course, we can build for gaming devices, IoT devices, web, Mac, AI, and cloud. And there's always been a unified framework and tooling behind it. We saw me use Visual Studio today, but I could build a lot of my applications in VS Code or Visual Studio and use .NET Standard to share it there. But with .NET 5, it's really a transition into saying, hey, there's multiple runtimes out there. There's .NET Framework, .NET Core, and of course, the Mono and Xamarin runtimes that enable me to build those applications. So with .NET 5, the teams started the transformation to modernize and bring all of these 3 different runtimes into a singular runtime that is just called .NET. Makes it simple. It's called .NET, and that's it. So it's a single SDK, single BCL, single unified tool chain that enables you to build for all the different operating systems, have cloud native and microservice support, cross-platform native user interface applications, cross-platform web user interface across all the different operating systems, and of course, be super duper productive and fast when you're deploying to Azure or other cloud backends. Now, the journey started with .NET 5, which released in November, and that is a current release, which is not an LTS or long-term support release, but .NET 6 this winter in November will be. And that's where the Xamarin and next generation of Xamarin Forms support will land. And it's really, really exciting. And just like .NET has unified into a single cross-platform SDK and BCL, the Xamarin team has taken a step back and said, well, what do we want to deliver? What do we want to deliver, but what do our customers want from .NET to build cross-platform native user interface? So today, you often have to make some compromises, whether you want to pick a cross-platform app, on Windows versus mobile, and how does it look? How does it perform, right? And Xamarin Forms 5 gets you a long way there, but there's still more operating systems on desktop that the team wants to pull in. So what the team is doing is creating the next generation or the evolution of Xamarin Forms that we call .NET Maui, and that is the .NET Multi-Platform App UI framework. And that just sits on top of .NET, which means that with .NET 6, Xamarin Forms will evolve into .NET Maui. And what that will give you as a developer is, of course, cross-platform native UI, a single project, single code-based situation and setup. You'll be able to deploy to multiple devices, including mobile and desktop. It's, of course, an evolution of Xamarin Forms, so your code will go forward with you. And additionally, it'll have first-class support for iOS, Android, Windows, and macOS from the beginning, which is great. And it's completely open source and already started in development today. So it's the next iteration. And I would say it's a lot more than just the next evolution of Xamarin Forms for not only mobile and desktop, but it's being rebuilt. Every single UI component is being built from the ground up for performance and extensibility. Everything is interface first and is extensible from the community. So when this transition starts, what you'll see is that Xamarin is directly integrated into .NET. So all of the repos will move over to .NET. Today, you have .NET Maui. you'll have then Android and Mac OS. So it'll just be Android for .NET, iOS for .NET, and then .NET Maui, which of course builds on top of those. But with this, it's a bigger evolution because it's integrating into the core tool chain. So things like command line, VS Code support. I mentioned iOS, Android, and macOS and Windows support. And the team is going to have experimental support for Blazor and Comet at launch. And of course, in the future, see how those experiments go. So let's talk about what .NET Maui is and what it isn't. Well, what it is it's focused on quality. So not only rebuilding those control components from the ground up, but it'll have 12 months of Xamarin quality releases as we're working on this entire 12 months from .NET 5 to .NET 6. The project structure is completely restructured. The names and classes have been restructured, so it's easier to contribute. Performance cold starts are under 1 second. Has responsive quick UI rendering, animations, and transitions built in, and reduced view nesting. It'll have a simple and elegant default UI theme, so your applications look beautiful from the start. Every control is extensible, and of course, cross-platform templating, similar to what I showed you with the radio button earlier. And of course, again, Android, iOS, macOS, and Windows. So I have a quick little video of some of the cool tooling things that are coming with .NET Maui. So .NET Maui introduces all the things that I just said. It gives you full support for building applications with XAML, like we've already talked about today, but also with C# and F# UI, and not only an MVVM, but also an MVU type of situation. But this demo is really cool because it enables you to see that it's going to have all of the great features of Xamarin Forms today built in, such as deploying directly to the desktop, getting hot reload built in directly from the start, creating your native desktop applications. But it will also enable you to quickly deploy to multiple operating systems without having to worrying about going and changing a startup project, going here or there. Here in my dropdown for debug, I can just select my iPhone. Here I was recording this demo for Scott, so I just plugged in his iPhone for him. And I can just hit deploy, and we can see that I'll have my iPhone device pop up right on top, as I would expect, and get nice theming across the board on top of here. But what's really, really neat is some of the additional work that the team is putting to really point out that this is a cross-platform app. There's only one project here. So inside of here is all of my code, all of my fonts, all of my images that are automatically resized for me. All my fonts are embedded for me into this one single project. All of my code will be here. So all of my models, view models, XAML. I could, of course, add more projects if I wanted to, but you can have all of your code here. And there's even multi-targeting. So I can go in and add Android, iOS, and Windows code directly under the platform little node here. So that's really, really cool. So I don't have to hop around from project to project. It's all directly in one project for me. So if I go ahead and walk through this, single project using the brand new SDK style multi-targeting, I can deploy to iOS, Android, and Windows directly from the dropdown. All my fonts and images and string translations are in one place, and all of my platform code is also in single place as well. What's cool about this is that, again, they'll have that first class support for iOS, Android, Mac, and Windows. Tizen will still be supported, and there are community versions that do target WPF and Linux as well. It'll target modern operating systems like Android API 21 Plus and iOS 10 Plus. Single project, you have the ability to use pixel drawn controls or native controls. It targets .NET 6. And of course, you can use Mac, Windows, or VS Code Visual Studio to build your app. .NET 5 was released in November 2020. We also have here, is there any code previews for .NET Maui? They're expected to ship some previews, with the .NET 6 previews, which ship sometime. I don't know exactly when they do, but whenever they do, that's the goal there. And another question here, will you be able to migrate? Absolutely. There'll be built-in tooling to help you migrate from your Xamarin Forms applications to .NET Maui. And there's even a backwards compatibility NuGet package. So every single one of your existing controls will continue to work, or that's the hope and dream, at least, as the team has been working on this there. So those are a few questions that I figured I could answer, as I do have control to pop on there too, which is cool. So that's it. I want to thank everyone for your time. I hope that you have a really great time here at .NET Conf. I'm streaming. Oh, we have a lot more people since I just started, so that's really good to see. I'm glad everyone is able to hop in over here, and I'll try to take any more questions if I see any on here. The Royal says that they like the hot reload stuff. Awesome. I think that might be it. Let's see. I can add in. There we go. Yeah, go for it.
Hey James, it was a really informational session. It was really great for me. I was never into Xamarin, but I can get started after the session now. So we got a few questions, not many, but we got a few. So which one did you like? It's like our sponsors are giving away an ebook to one of the person who asked a question that is selected by you. So whom do you want to give it to?
Well, I always like a good question of, from this one here about migrating that I answered earlier. If that was someone that can get one there too, that's good, because I always forget to mention that. But yes, you can start building your application today, and you can migrate immediately. And for Tanzil, UWP is not going away. It's actually, UWP as a platform is a core fundamental piece of Windows. The UI component library is transitioning into WinUI and WinUI 3, and Xamarin Forms already uses WinUI 2 today, and .NET Maui will use WinUI 3 as well. So there's that. So built in right from the start.
Okay, James, there was one question from my end. How is Blazor related with Xamarin? Like you said that they've...
It's a good question. So there's actually a project out on the internet from the .NET and Xamarin team called Blazor Mobile Bindings. And this is really cool because it enables you to leverage sort of Blazor Razor pages and Blazor project systems and web controls inside of a Xamarin iOS and Android application. So you can use all of those controls from Xamarin Forms that I showed you today in a sort of Blazor hybrid application. It's definitely something to look out for. It's called Blazor Mobile Bindings. So if you like Blazor and you like using Razor pages, you can go ahead and check that out today. It's an experiment, but it's something that we're learning a lot about, and we want to enable that scenario. So you can sort of, use Blazor in your .NET Maui apps and .NET Maui in your Blazor apps, and it's like one beautiful world. That's what we're hoping for.
That would be really interesting to explore. Yeah. Thank you, James. Thank you, James, for helping us and having such a wonderful session. Everyone enjoyed it, and thank you. We're looking forward to have you in our future events.
Awesome. Well, thank you so much, and thanks for having me.
Thank you. Okay, guys, that was James, and let's move on to the next session. And I would like to invite Nesh to join in, and he's going to talk about microservices and .NET. Hi, Nesh.
Hey, thank you so much for having me, Ashravad. It's wonderful to be here. This is the first time I'm actually speaking at the Bhubaneswar meetup, and very, very excited. Good to see you guys really stepping up and doing this amazing community stuff. And it's a Sunday afternoon, and it's going to be fun now. So we're going to talk about microservices today. So that's microservices in .NET. Well, I don't have any more slides. Okay, we're going to do completely demos today. And the way we want to do this is because, we are trying to interact with the community. So feel free to ask your questions directly on the YouTube chat, and we can pull that in and talk about it. So mostly it's going to be hands-on demos. So someone who's getting started with microservices will start from scratch and go into the details, and we can go into depth as much as you want, right? So my name is Nesh. I work on James's team. We are the .NET community team. I'm a PM. I specifically focus on .NET/architecture. If you haven't seen the site, you should just go check that out. We write some amazing production-ready guidances for building production-ready .NET apps, right? So, and that's my handle, Nish Anil. So if you want to follow me afterwards, ask questions, that's all. I'm on Twitter, Instagram, GitHub, everything. It's the same handle there. All right, so let's get started. So if you want to get started with microservices in .NET, all that you need to do is, let me just bring in my browser here. There you go. You just go .NET. And right over here in the home page, you will actually see something called as microservices, right? Go into this page, and here, there's so much of information out here. Like, what are microservices? Basically, microservices are a design pattern in which applications are composed of small independent modules that communicate with each other using well-defined contracts. So what does that mean? Well, you know, microservices is not all about taking your service and making it small, right? Its most important thing out here is making sure you build the service with a definite business boundary. That means every single service that you're building has a bounded context, and it's mostly managed by independent teams, so that you have that autonomy to ship applications really fast. You see that today, with all the applications out there, things are moving so fast. People are actually committing code to production 100 times a day. So how do you get that kind of power to do that? And that is when you actually choose a design pattern that will fit the kind of need that we have, right? So we have a lot of information out here that you can go through. One of the things that mostly talked about whenever you see any particular microservice session is it talks about Dockers and Kubernetes and other things, right? Well, does Docker and Kubernetes make any sense to microservices? It does, but it's not the most important thing, because microservices architecture is just a design pattern, right? So that's the choice that you make, but it doesn't mean that you need a Docker or containers to go with it. You can actually do it without that. But the advantage that you get is like the kind of things that brings in, that actually adds up, and it actually makes the really about deploying and building complex application much simpler when you use tools like this. And that's why we often talk about it in together, right? So there are some really amazing things out here. So what I want to leave with you today is basically to show you a bunch of resources. So if I have some demos that we can go through from getting started to maybe talk about some resiliency in microservices and other things. But I want to mainly leave with you the kind of resources that we already have that you can get started with. For example, if you're completely new to .NET and microservices and you want to see how do you start building microservices, well, at the start of any building microservice is basically having an endpoint for services to consume, right? So you'll start to build service endpoints. So that you can start with here. There's a get started section here. So I'm going to open this. And I want to show you how easy it is to get started with .NET. So if you go into the section here, it says install .NET. So all that you need to do is click on this. It'll go and download this SDK for you, install it on your machine. That's it. You don't even need Visual Studio. And that's the easy thing, right? And you can actually run it on Windows, Linux, Mac OS, wherever you want to be. So if you see, we also talk about Docker. So because we want to help you containerize the application, because Docker makes your applications into an image, which are immutable. So you can easily ship for things faster. You can have multiple images running in production environment, and kind of make an API gateway decide which version of the application needs to be hit and all those kind of things. So you get those kind of advantage. So you get started with these things. And at the end of this, you also have another section called deploy microservice to Azure. If you go here, it also talks about like how do you take this Docker image and kind of like push it to production, right? One of the scenarios is to have push it to Docker Hub, which is a container registry. So any kind of image that you kind of build, it needs to be shipped to production through some kind of registry or container registry there. And that's Docker Hub is one of it, and it's kind of supports a lot of free versions out there. So we kind of like give you that option to start with Docker Hub, but you can also choose more secured ones like Azure Container Registries. And if you are actually deploying finally into Azure Kubernetes service and other things, you can use the ACR and make use of the security between the Kubernetes and ACR there. Right, so you have these options, and at the end of it, you had to write some YAML scripts here to kind of define where does this container registry, where have you pushed it to Docker? How do we pull this back into the Kubernetes and then finally deploy it? Right now, if this is completely new to you, you don't have to really worry about it. All that you need to do is just go step by step, and you'll eventually get there. Now, for those of you who already have a fair idea of how these things work, because you are in the industry for a very long time, you know how to ship building applications, specifically the monolith ones. Now you're looking at how do I kind of have this scalability in my application and make use of cloud and go deeper into understanding how do I design applications using microservice architecture and things. There is something called as architecture guidance. And this is exactly what I was talking to you about when I started. This is where I live. I am a PM on this one, which is building reference guides, building reference samples so that you build production-ready apps with confidence with .NET, right? So here, if you go to the .NET, there is a tab called Architecture. You go there, you get a bunch of resources for you to get started. So in one of the things is microservices. So if you click on that, watch this. There are free ebooks. And the beauty of these ebooks is I can just click on it, and it just downloads. No questions asked. We are not asking you your emails, first name, last name, none of those kind of contact forms out there. It's just free because we want to share our experience building microservices with you. So here's high quality PDF that you can actually take it and start reading it offline, or you can actually go into this online material, which is view on the web. If you go here, it'll have all the information right here online. And this is something which we maintain it heavily, which means we constantly listen to feedbacks, we update it, we work with customers understanding how are they building it using .NET, and we update this based on the feedback that we receive from most of the customers as well. And if you find something interesting where you think you can contribute to this, you can do that because all of this documentation is open source. So you can actually hit on this, edit this document, go into this GitHub page, go to the Markdown file that you want to edit, and send us a PR request. That's it. And we're going to work and reviewing it and then push it finally to this book, right? So what is this book all about? This book is all about building microservices. So this talks about how do you kind of define your business domain using DDD, that's domain-driven design. How do you leverage Docker and Kubernetes for your microservices? How do you use CQRS pattern? How do you use some of the other things how do you secure your microservices? There are a lot of things that we have written in this book. And there's also another book, a complementing book, which is the Cloud Native ebook, which is when you're ready for production and you choose Azure as your cloud platform for deploying your application. Then you need to decide on what are the managed services that you can go with. So we wrote that for you. The decision making that you need for you to get started on Azure, we have wrote it down. So that is also available for you free again, right? Now, you can go further down. I'm going to talk about these microservices tutorial in a bit, but the other thing that we also maintain is we not only tell you how to do it, we'll also show you how this is being done. And that is this beautiful application called eShop on Containers, which is one of the popular reference samples out there in .NET. And you can see the popularity, the kind of stars out there, people watching it, people contributing it. And this is something which we maintain every single day. So if you go into this application, this is nothing but a simple e-commerce application, right? So why e-commerce? Why do everyone talk about e-commerce when it comes to microservices? One of the reasons is because e-commerce as a domain is easily understandable. That is all the reason it is. But you can actually build microservice to any business domain. It doesn't stop you from doing but taking this to maybe, healthcare domain or to manufacturing domain or even to the finance domain, right? So there's nothing stopping you there. It's just that, it makes it easy for you to get started with understanding microservices, because with microservices comes the complexity. So let me go down and show you the architecture of this reference application. How does it look like? Now watch this. This is a simple e-commerce application, but it has a multiple services that is working with behind the scenes. Look at these services. There's identity services taking care of the authentication authorization. There's catalog service, which is actually showing the all the products on the page. Then there is ordering microservice, which is taking care of order. There is basket, which is basically nothing but the cart, and there are a few other services like marketing and locations and other things. Now, so what exactly is happening behind the scenes? If you pay attention to the architecture, you will also see the database of each service is different. It is not a table, a reference table, or some kind of foreign key, primary key relationship. The database itself is different. That is what brings in that scalability aspect to you, right? So that means if there is some change in catalog microservice, you can very much go change that without really looking at how you're going to break the other services, because the services are going to work with the endpoints directly. They're not going to reference any of your databases directly. And that's the key aspect of scalability, right? So now in an e-commerce scenario, when there is probably a Diwali sale or something like that, you can actually improve the catalog microservice, because there will be a lot of shoppers who are just seeing what are the catalogs available, and then you can actually increase those services up high up, right? And then there are situations where you may use other services high up. So those kind of flexibility that you get when you go with microservices design pattern. Now, I said how these services work with each other is by service endpoint. There are two ways doing that. That is synchronous communication, and there's another way to do that is asynchronous communication, right? So for asynchronous communication, there is event bus like RabbitMQ, Azure Service Bus, and other things. And then you can see there's another thing called API gateways. That means you're actually, since they are like multiple services, they all have endpoints. Do you have to expose all the endpoints to the end user? Not needed. You can actually decide that at the API gateway. So you can choose an API gateway to accept requests. So all that your clients will know is just the endpoint of the gateway, and the gateway will actually take care of making a connection to the service that it needs to connect to, right? So there are a lot of things like that. So these are the patterns I was talking to you about. So these are for people who want to go deep into it and you want to get started with changing, maybe taking your existing legacy application, modernizing it. You want to understand how these things work. We have these things written here, right? And if you'll go into this repository is very, very simple. Like all that you need to do is just bring this code down to your local system, install Docker, make sure your Docker is configured really well to handle this kind of services load, and then build this. It takes a while to build it because it has to build most of the services independently. And then you do Docker compose up, and then it'll just keep the site up, and then you can actually start working with it. Now, the reason why we have this, one of the anti-patterns for microservices is to have all these services into a single repository, because, I talked about being autonomous and being able to scale. That means even every service should be in its own repository, right? In this case, we don't do that. And the reason for that is to make it easy for you to get started, right? But what we also do is we actually take care of the CI/CD pipeline to be independent. So you commit a code to just the basket service. It'll only go and build the basket service and push it to the Docker Hub, right? So it makes it very, very easy to get started. Okay. Cool. So now let's get started right now. For those of you wondering, okay, how do I get started with microservices? I want to show you to get started with .NET and microservices. So let's go back here. And if you want to get started with .NET, you just say get started or download .NET. All that you need to do is just go to the download, get the latest version of .NET installed onto your local machine. So download from here. In my case, I already downloaded, so I do have it here. So let's get started here. So this is my CLI command line PowerShell that I'm using. So if I just say .NET version, it'll give me the version that I'm working with. So that's the latest version. And if you want more information, you can do .NET -help. So it'll give you most of the commands out there for you to get started. So in our case, we're going to start with something very new. So we just say .NET new, and we want to provide, what is that new? Like, what am I trying to build, right? So if you just simply hit enter, it'll give you those templates available for you to get started. So there are, if you're starting with WPF application or console application, you basically go with the short names right after the new command. In our case, we're trying to create an endpoint to our microservice. So in my case, I can use either the web API, which is the REST-based client, or I can use gRPC. I'll show you both of it. Okay. So now let's get started with web API. So I'm just going to say .NET new web API, provide an output directory, and let's call it as hello hello service. I may have it, so I'm just going to add an X to it, just in case I've just created this demos before. So yeah, that's all I'm going to do. Hit on enter. So it's now going to create this service for me. So basically the O is basically the output directory. So if I just list it, there you go. So I have my new service there. So I'll just go into that and right. So if I want to build this, I can just do .NET build. So this is going to go and build the application and hit a .NET run. So instead of doing that, what I'll do is let me open this code so that I can show you what is there in this code in Visual Studio Code, right? So there you go. So it opens up in Visual Studio Code. So you have the startup.cs. This is where you actually wire up things. And let me just run it, right? So let me go into the, just give me 1 second. Okay, so let me show you this. Basically, what we do is we just give you a template to get started. And for the demo, we just show you how to build a weather service. So there's a weather forecast controller, and there's some random strings out there. And we just create some random values here. See, why do I say random values? Because obviously we do choose new random, right? So there's random values out there, which is actually running. I'll just write a piece of code here just to see where exactly am I running. So I am going to use logger, which is basically these are the nice things about ASP.NET is like you can make use of the dependency injection. So the logger gets injected into your controller. So now you can just directly use logger dot, and I'm going to use a log information, and I want to know where this service is actually running. So I can go and say OS version string. So this is going to tell me where exactly am I running this application, right? So let's run this. Go to the debug. I can see there is the .NET Core launch web. I'm going to hit run. That's it. You can also do .NET run on the CLI. You see that? There's nothing there because we have a controller. So one thing we did in .NET 5 is we actually wire Swagger directly for you so that you don't have to write this code yourself. So now with the Swagger definition can actually look and tell you what are the available endpoints. So by default, I showed you the weather forecast controller. So I have the weather forecast controller here. So if I just say try it out, execute, there you go. There's this random JSON data that is getting fired, right? Now go back to my code, Visual Studio Code, and let's see if there is something logged in, right? So you can see it is basically running on Microsoft Windows NT 10.0.190, whatever, right? So there's no fancy here. .NET is running on Windows. I'm on Windows, which is great. So we have this information right here. Now, if you want to directly access this URL, you basically /weather forecasted and you can access it, right? Now, to save time, let's go to the next step. So now we talked about Docker being one of the amazing things to use when you start building microservices. You have the ability to actually containerize your application and run it into production where the Docker host is running, right? So now let's containerize this and ship it as an image, right? How do you do that? Right, I'm in Visual Studio Code. I can do that right from here. So all that I need to do is Control-Shift-P. And there is an interesting thing that you can call it as add Docker files to this workspace. And Docker file is the key for you to build the Docker images. So I'm going to hit on that. And the next thing it's going to ask is, what platform are you trying to build? In my case, I'm actually building an ASP.NET Core, which is great. Now, the very next thing that .NET runs is multi-platform, so it can run on Linux and Windows and Mac OS too. But since we are building Docker files, it matters only whether we are building the Docker image for Linux or Windows, right? So in my case, now I'm going to build it on Linux. And the very next thing it's going to ask me is like, what port am I running on? So in this case, I'm running on ATN 443, which is great. So I'm going to hit on enter. That's me. All right. Do I have to add a Docker Compose file? Well, Docker Compose file will be more meaningful if we had multiple services that we're working with and we want to do a Docker Compose up, or you want to run this in an orchestrator like Docker Swarm. But for now, we don't need to. So I'm just going to say no to that. So what this is going to do is it's going to add two files. One is the Docker file. There's one Docker file added, and then there's going to be a Docker ignore file. Basically, Docker ignore file, if you've worked with Git ignores and other things, ignore, basically what ignore files tells it to do is like ignore these files for me when you're building images, right? That's all it is. So let's not look at the Docker ignore file for now, but we'll go into the most important file, which is the Docker file. Now, everything you write inside a Docker file is basically a command for the Docker to build the Docker image. So in our case, we start from in an image. What happens is like you actually can say, instead of starting from scratch, you can say, okay, I want to base my image out of somebody else's image, which is already built. In your case, you obviously need, because you're your .NET code, so you need a .NET runtime to run for it. So we are actually taking this image, which is the ASP.NET 5.0, because this is my ASP.NET application. So I need this image to be based out of the ASP.NET 5.0 image. So I just create that. And then we also do one more thing, is we don't not only building, not only we are actually bringing the runtime, we're also bringing in the SDK for this, which means I'm going to build my entire source code of the .NET right inside the Docker image itself. And then so that I can just push it to, so everything that is there is all there in the Docker image, right? So it's everything is inside that. Now, if you'll be wondering, how does the Docker image know which operating system to run on things? That's because your base image, while building the base image, that image would have referenced something else, right? So because we have explicitly mentioned we want to run it on Linux, so this command is going to actually bring in only the Linux images, and your image is going to be based out of the Linux image that we chose from, right? So there are a few codes like .NET build, .NET publish, and so whenever .NET Docker is running, all that it needs is an entry point. So we just say, just like how you would run it otherwise without the Docker, you call the .NET and your DLL, and that will invoke your program.cs main method and fire up all what is needed. In our case, it's going to be the web API, right? So that's what it's going to do. So now I go back here to run it. Now I want to run it. That's all. Just created the Docker file. And you can see one more thing here, which says docker..NET code launch. So I'm not using .NET code launch anymore. I'm going to say, I want to run this as a Docker image, right? So to kind of like take it to the next step, I'm gonna put a breakpoint here to see where am I running, because remember I asked I want my image to run out of Linux, so I want to make sure it's running out of Linux. So I just go and hit the run command again. So I put a breakpoint here. So there you go. It just I think I ran the wrong one. Let's stop this, because how do I know that? Because it gave me the 5001 URL, which was configured for the web. So I'm going to use docker.NET code launch, and I'm going to hit the run again. Now you can see this, it's acquiring the .NET debugger, because it's going to work with the Docker right now, and it's going to build the Docker image. So if you look at this, if you pay attention to this thing, you can see that how it is basing out of particular image that we already mentioned, and it's going to build that, and it is going to put me into a new port, which is the 49153, which is a port that is actually running inside the Docker. Now, how do I know that? We can actually hit the weather forecast. That's the end URL. And let's see what happens. Oh, we hit a breakpoint, right? Now at this breakpoint, I want to see where am I running. There you go. So it's running on the Unix 4.19.104, right? So that was that easy to basically containerize your application and run it as the Docker image. So now your .NET code is running on Linux on Docker. Now I can take this to the next step, which is do a Docker push command. Once I build this image, Docker build with a tag maybe, and then push it. So once I push it, it goes to a container registry, as I said, and that from that container registry, everyone else can use it. For example, how did you use the Microsoft's ASP.NET image? That's because we write from that image, so it knows it's going to pull from Docker. Similarly, when you do Docker push, it's going to be pushed into the Docker Hub container registry. In my case, it's I've configured the Docker Hub to my personal. So if I just push through that image, if I open this, I have this niche channel. So it would just go and push it to this image. So right now I don't have it, but if you want to see the same code running, you basically have to pull this hello microservice image, and it'll have everything that you are looking for, right? So these are registries, and even Docker Visual Studio Code has really nice tools that you can work with. So if you want to, sometimes you're running, you want to see what's happening in the log, you can actually take an image and say like, okay, view logs, or you can, want to debug the running container, you can just hit on attach shell, or if you want to inspect it, you will have those commands and a thing. So you don't have to really, these are the amazing things that are baked into this extension, this Docker extension that you can add it to your VS Code, and all these things come to you. All right. So now that's about containerizing a simple REST API. Now let's talk about gRPC, which is the newest form of creating the endpoint. So we can also start with gRPC right here inside the CLI, say .NET New, gRPC service and things. But I want to show you Visual Studio. So if I were to work with Visual Studio, you can very much do the same things here to create a new project, choose web API and things. In my case, I'm going to use gRPC. So I can just search for the gRPC, and there you go. So there's gRPC service, which is now going to be the endpoint, and I'll explain to you in a bit. So it's going to create gRPC service 5. So click on create. Now, okay, there's ASP.NET Core gRPC service. I am choosing .NET 5.0, which is great. And hit clear. If I want Docker support, all that I need to do is just enable this. So this will take care of adding Docker file to this. But I'm just going to keep this simple for now. You get the point, right? So I hit on create. Now, what is gRPC? Unlike REST is more like human readable format, right? You hit a breakpoint, that's going to be a JSON, and you write machine to kind of serialize this and work with your C# objects, right? In gRPC, it's mostly a contract-first approach, which means it's more like WCF. You've worked with WCF in the past. It defines a proto-file, and it'll tell you, okay, this is my contract, my service, which is going to be the greeter service. It's going to have an RPC method called say hello, which accepts the request, and it returns a response, which is the hello request and response, which is right here. Now, this is not a C# code, right? What this is it's simply a protocode, which is basically, this is how it's written. I mean, if you are taking this to another language like Go, you would write exactly the same. So it's a well-defined contract. Now, I'm going to just build the service. Let's do this. And let's run the service. There you go. So when this runs, it actually gives you this URL, https localhost 5001. Let's go in at that port, https localhost 5001, and hit enter. Now you see this message which says communicating with gRPC endpoints must be made through a gRPC client. As I mentioned to you earlier, when you talk about REST-based clients, they are basically humans can read it. Now we're talking about the clients to communicate, or the machines to work with each other, and that's because under the hood they're all binary, so you can't read it, right? So you have to work with a binary stream, and it is your entire connection is on the binary. Now in WCF we did this in the past as well, and that's why. But now what has happened is gRPC has become one of the most popular RPC framework out there because it's performance. It's really amazing. It's cross-platform. It can work on Windows, Linux, and things. It can work with any number of languages. You can have a gRPC service written in .NET, and you can create a gRPC client in Python and still work with each other, right? And there are a lot of other things in gRPC, but I'll encourage you to go check the documentation for these things. But because we want to keep this simple, we will just stick to this, right? Now I want to create the client to connect to this gRPC service. Now, how do I create the client? I can right-click on the solution, go to add a new project, and now choose a client, any client. It could be a WPF, WCF, whatever, right? In my case, just to show this as demo, I'm going to use a console application, which is going to be fairly simple, right? So I'll just take this gRPC service 5, copy this, put this here, this into a client code, create. What this is going to do, it's going to create a console application. Now we need to kind of reference, like, how do I make this client connect to this gRPC service, right? As I mentioned, between both the service and the client and how the machines can talk to each other is by a well-defined contract. And that contract is the protofile or the protobuf file, right? So I need to point that to the protobuf file. I can do that in Visual Studio. We have some great tooling support. So I just do add, right-click, add, hit a service reference. So that's what you need to choose, okay? So right-click, add service reference, and it's going to give you this UI where you can go and add the service reference. Now, by the way, this is just a tooling support. You can also add Open API, which is the REST client, REST service if you want to connect to. But in my case, it's gRPC. I'm going to hit next. Now I want to point it to that proto file that we already have it, right? So I just go to gRPC service file client, go into this, protos, point to this proto file. Hit on enter. And now it's also asked me, what am I trying to build? Am I building a client or service? I can do that. So you need this sometimes, from your services that you're working with, maybe something totally external, third party. All that you will get is a proto file. From that, you can choose to decide. I mean, most of the cases you will be building a client because you will be connecting to it, but who knows, you may want to build a service yourself, replicate a service or something. You can actually create the server out of it. I'll tell you where exactly this makes a difference is basically in the CSproj file. So in this case, we hit finish. So it's going to add the necessary toolings, NuGet packages that are needed. And you can see this proto file is also there here. Now I can start going and building the service, right? I can make sure that this is being connected to that. Now I'll just write some code. So I'm going to remove this main method, which is the default one that comes with it. And I'm going to add some new code here. So what we're doing is, just like, if you were working with gRPC HTTP client, you will use something like new HTTP client and then provide an address to it. In my case, I'm working with a gRPC client. So this is the code that you would say. You want to create a channel from the address, which is, in my case, I've hard-coded it because we started the 5001, so we can hard-code it for now, for demo. For production, you probably want to inject this code into us inject this using configuration and CI and other things. And then you see this greeter client. So what happened here? How did this code exist? And that's because we generated the client for you. So there is so much of code that has been generated, which would be otherwise needed for you to write. So that's the tooling support that comes into play, right? So so don't edit anything that is on that file, because this is all auto-generated. So if you want any changes, you can go and edit the proto file. If anything changes between you and your contract, the contract changes, you go change this and then allow the tooling to kind of make the rest of the things for you, right? And then it just says say hello async. That's because if you go to the proto file, it has this method called say hello. It accepts hello request and it responds with hello reply. And that's exactly the C# code that just got created. It has say hello async. It provides you with a hello request, and it is going to give a response, which in the case in the response message is the message that is going to come. So now I want to show you what exactly is that service that was created. So within greeter service, if I go, it has a say hello method. So now we're looking at the server-side implementation of the gRPC code. So which is this method. All that it's doing is whatever comes in, I'm just going to add hello to it, right? That's all it is. So if you come back here, so there's console.writeLine response.message. So it's going to say, since I'm going to send .NET Conf, it's going to come back and say hello.NET Conf, right? Just to keep this on the screen, I'm going to add another code here, which is console.readline. And that's about it. I'm going to build the service. I recollected that I had not built the service at all. So I'm going to do that right now. And when it is ready, we'll also run it. So let's debug this, start new instance. It's just running the service, right? And now if I go to the client, debug, start new instance. So it's going to connect to the backend and it should be. So for some reason, it didn't work. Let's see what happened there. Okay, I'm going to build this again. I think what would have happened is because we are referencing the same directories, the building would have been blocked. So let's try that again. Okay, it's making an error stating the gRPC call. So let's see what happened. Rebuild. So it says rebuild also succeeded. Rebuild. Yeah, I want to run this and get this thing running first. Let's see what happens. Okay, that's weird. There they go. So that's running. Now let's go back and start this new instance. And there you go. So it just went and hit the service and got back this response. So now why choosing gRPC as an endpoint? Performance. So if you care about performance and you don't care so much about the human readability aspect, then start with gRPC services. I'll tell you where we use it in eShop and containers is mainly scenarios where we have API gateways and other things where for us, performance was the key factor there. So let me show you that. .NET architecture, eShop and containers. So within this code, there's something called as API gateway, which we built. So here there is something called backend for frontend that connects with these services. So we built everything that service to service communication into gRPC because at this point of time, all that we care about is the protos as a defined contract and then just work with each other. So we don't need any kind of like human intervention or readability and all kind of things. So we moved away from REST and went with gRPC there, right? There are still API gateways where the endpoint is still exposed to REST because there would be older clients which don't have gRPC support, which needs to work with. You still can work with REST clients and things like that, okay? All right, so that's a little bit about gRPC. Now let's go to the next level, which is like, which I want to show you is the tie. So in a typical typical scenario for microservices, you will probably have more than one microservice. In this case, we have backend and frontend. So I'm going to open this. Let me go to the backend. So if you want to run this, what I do is go to .NET Run. Okay, that's my backend code that I want to run. So that's going to build and run. So it's running on 5900, or in case of HTTPS, it's running on 5901. So now I go to the front-end code, right? Just like you saw me do with gRPC server and then client and things like that, like you run multiple times, right? So I do a .NET run, just make sure that I'm in the right place. Yes, do a .NET run, right? So it's the same weather service that you saw, which has the JSON, but now it has a nice UI to it. So now I have this front end, which is connecting to the backend and getting that value. So I just copy this 5903 here and go to my browser. There you go. There you go. There's a pretty UI. I call it pretty because this is the maximum a developer can build, right? You need much better designers to do some nice work. So all that I'm doing right now here is just hitting refresh, and then it just goes and connects to this 5901 port, which has the weather forecast, giving you that random value and running it. But imagine if you have multiple services, right? You need to have multiple ways to run this, right? You have to run .NET. One of the ways to do this is containerizing using Docker Compose and things. But wouldn't it be nice if we could just do something like this? Like something like tie things together. So I just go to the main folder and say tie run. We do now. So there's something called as tie, which you can actually go and download it from. And every time I bring the browser on, it goes to a different place. Okay, so let's do this. GitHub, or you can just simply search for .NET tie, and you will hit this first URL, which is the GitHub repo.NET tie. So you can go and download. There are instructions on how do you install tie. Basically, you install as a global tool. So once you do that, you have tie available to you. So now you just do tie run. What it does, it gives you this nice dashboard. So let me open this dashboard. Go here. There you go. So it'll tell you what are the services available. So what it did is basically, I also had an SLN file in my directory. So it looked at the SLN file and it figured out you have two .NET projects to run. So it ran this .NET project. So if you go into the details of it, there is metric of your .NET files, .NET project. There's also a log file. So you kind of get it, right? You know, you're building a cloud native application. You need the dashboard, you need logs, you need metrics. You want to see how many replicas you have. If you want multiple replicas, I can do that for you. Have multiple backends, have one front end, work with multiples and things like that. Do that load balancing. So now Thai does all these things for you at the development stage, right? What it also did, it also created some bindings for or the ports where it is also working. So see this, it's no more finance 01 or finance 03. It's some random port. So let me hit on this open new tab and let's see what happens, right? So I'm hitting the front end. As you just expected, it's actually failing. And one of the reasons why it's failing is it was actually looking for localhost finance 01, but Thai had already run it on some other port, and there's no more backend service running in finance 01, right? You can also go and see it in the logs. You'll see the details of the exception that came in and that kind of things. Very nice, handy stuff out there. Now let's go and fix this. Okay, so usual developer thing that people kind of like hard code everything every day. So we should fix that. We open this code and we just see a code and go. My front end is connecting to the back end, so I should go to the front end code and find out the code where actually I have written how do I connect. So which is in the startup.cs. So there you go. So it's written hard coded here. So I'm going to comment this out, and I'm going to uncomment something this. Is configuration.get service URI. Now it says get me from the configuration a service URI whose name is backend. How did that backend match? And that's because when you remember from the dashboard, Thai was actually adding something called as front end backend, which is nothing but simply your CSproj files, names of these projects, and it's just created by name. You can also type name whatever you want, which we'll look at it later with the Thai configuration. But in this case, I want to make use of the default thing, right? So I have this backend added. Now it should all be working. Now before having this URL, this is an extension method on the configuration. To have this, all you need is also another library called microsoft.thai.extensions.configuration. So make sure you add that NuGet package. Once you add it, you have this method, and now no matter what port Thai assigns it, it'll going to pick and just start working, right? We can try that out. I run. Go back to the dashboard that we already had. Refresh this. Go home. Back in. Hit. There you go. So we are back in track, right? Now, this is pretty nice. But now I want to take it to the next level, which is I want to add some data store to my application. Now, like every other microservice, you will have external dependencies or services that you want to consume into your application. So in my case, I want to add a caching service to this, or have a backend cache my. So every time I hit, weather, I don't want a new value. I want a cached value for a few seconds because weather is not changing every second, right? So we can cache it. So how do I do that? I can use something like a Redis cache to do that. Now, okay, I want to add Redis cache. Now, how do I bring Redis to it? Should I just go and go to the Redis and get installable on my Windows and then install it and then find the port, run it and things? You don't have to do any of that thing. And that's what Thai makes it easy to do. Let's see how to do that. So I'm just going to say Thai from here, say Thai init. Now, this is what is important because this gives you this new YAML file, a configuration file for Thai. So this was what was happening behind the scenes. Since we already have an SLN file, Thai is aware of how .NET projects have to be run. It didn't need the YAML configuration file, so it just picked up by default. But if you want to explicitly change the name of it and other things, here's how you do it. You just create Thai.yaml, tell the projects that you want to run, what name you want to add. Now, we're going to add a Redis cache to this whole thing. To add Redis cache, I'm going to use, I'm going to copy some code from my previously executed projects, so which is this one. So all that I need to tell Thai is I'm going to bring in Redis. And how do I bring in? I bring this no more as a project, but as an image. There you go. So as long as you have Docker, and now you can actually work with images, you can actually bring those image down. All that you need to see is Redis. Now, if you have images elsewhere, which is like acr.io or something like that, and not Docker Hub, then you provide the full name to that, right? If you just simply give the name, by default, it's going to look at Docker Hub. And pretty much all the tooling in the cloud native world does that, right? So we retain the same thing. And you tell them what port that is running and all those kinds, right? Now that you know that, if as long as I have Redis :6379, my code is going to connect to this image and work. And Thai will take care of running this. So I just have to fix my code to take the caching. Now go back to my code. In my case, weather forecast controller. I have this random value that we saw that getting generated. I'm going to comment this code right now. And I'm going to bring in a new code, which is the same get method, but this time it is going to have the implementation for caching. So it's going to create random values, right? But then it goes and sets a cache for it. Now, how did all these things work? That's because we're injecting an I distributed cache. And again, as I said, like the beauty of ASP.NET, you just ask in your method what you want, and that gets populated, right? So now if you go into my startup.cs, so this is where it is. So we use a NuGet package called, let me show you instead of this one, Microsoft extension.caching.stack exchange Redis. So as with this package, we'll take care of populating that for you. So now I go back and say, okay, this is my client, basically that needs to connect to the Redis cache. And how do I pick this? You use get connection string Redis. And again, this is configured in your YAML file in Thai. So now it connects to the, whatever is the name, Redis :6379, you're set. Now when this code is running, it is going to actually push it into the Redis cache and is going to retain it for 5 seconds. So after 5 seconds, the cache will expire and it'll just regenerate this code. That's all it is, right? So now let's go back and run this code again and see if this whole thing works, right? So go Thai run. You probably would have seen I'm not even doing .NET build, right? And that's because Thai will take care of doing that, any changes if that happens. And I can also do Thai : --watch, and I can just simply write the code and save, and Thai will do this building and then running it again, right? So now you see there's a Redis cache that came in with all the support. And now if I go back to my dashboard here, and there you go. So now it says, hey, I'm going to run Redis on the container. It's not running as a project. So Thai is smart enough to know that it's a .NET project, and Redis is not a .NET project because we wrote it in the YAML file. So it pulled the image, it ran it as a container. So now it's exposed this port called localhost 6379. It can go and work with it directly. So I hit on this, refresh. Oh, there is error, right? What happened? Why is this error? That is because I deliberately injected some error into this as part of another demo, which we're going to comment this right now, because if we have time, I can go into these as well, but I will probably want to take more questions. And go back. I'll run again. Okay, so go back to the dashboard. Everything's running. And now everything is working, right? Now if I refresh, you see that the page is not refreshing. That is because it is now pulling from the cache. Now they go, every 5 seconds, there's a new value, right? So we just implemented a data store without any dependency on the system, right? We did not bring Redis. We just told Thai how to do this, right? Let's take one more step further is, when you're working with cloud native applications, you also want to bring in few cloud native tools to make things easier for you to get started. And one of the tools is basically Zipkin to understand distributed tracing. Like I want to understand how many services exist, how long these services take to respond to queries and things. So easiest tools to use that is something called a Zipkin. Okay, so I'm going to use extensions here. So when you do YAML files, be aware of the spacing that you need to give. Otherwise, things can be pretty messy. Use all that I'm going to say is extension Zipkin. That's it. And now run this again. So there you go. So now it's going to even pull the Zipkin as well. Go back to my dashboard in the new. So there you go. There's Zipkin as well. So I can hit on this URL, and there you go. There's Zipkin that just came in, right? Run query, nothing happens because we never actually hit the URL. So let's go and hit the front end URL. Now go back to Zipkin, run this query. There you go. Now it's going to tell you how exactly your application worked. So here it is, the front end, which basically connected with the back end. You can see now, go into the detail and see, okay, the front end connected to the back end, and it took about 32 milliseconds, I don't know, to respond to this, right? So it gives you all those details. You can also look at the dependencies and to see like how the front end and back end works. So I can just do some refresh, and you can see this thing kind of like making this request, and it'll tell you those details that came in, right? So we just added these extensions without really making a lot of code changes, right? All that we did is just add YAML configuration to it. So there are a bunch of things available with Thai today, and it is still in preview. So it's something we want to know, like how would you use .NET and Thai, and how do you use, what are the tools that you would need to build microservices, and give us those feedbacks, right? So that way we can make Thai much better. So this is the URL Thai. This is where it's going to be. I have a few more things to the demo, but since we are going to run out of time, I'll show. I think I wanted to show you one more thing with this demo, was this one, which is basically if you have errors like resiliency, right? In a microservices world, when you're working with multiple services, some services can fail, and that failures can be intermittent because sometimes Kubernetes is trying to build your applications, or it is kind of change the application ports and other things. So there could be intermittent failures. How do you gracefully handle those things? So we use something called as resiliency, and there's two ways to do resiliency. One is using polycode, which is also here in the back, I think in the front end. Yeah, here you go. So we had policies basically using a library called poly, and we define these policies as like if there's an error, we don't want to immediately tell show the exception, but we can actually retry. We can handle that retries, and you don't retry immediately because you keep retrying it. There could be denial of services, so you want to wait and retry. So you provide some jittering algorithm to say, okay, how long do I want to wait and retry? This is the exponential retry that we are talking about here, and maybe by the time things would be back on, and then your services can start working. Right, and then there's also policies like circuit breakers and other things. We can also implement this entire policy in service mesh, which is the next level, which is Linkerd. You can actually see all these things here. I'm going to leave these things to you so that you can try this yourself. So this is my repository in channel, and I did this whole thing in the on.NET show. You can also check that out. So if you go to the repository, on .NET. So this is the URL. I might as well paste this in your YouTube comments. You can directly hit this place. You can, if you want to see how this is all done, you can go to watch this show. But here is the step for you to execute. Like you can install Linkerd and see how this thing all works, right? Now, for now, I was actually just doing Thai, deploy Thai, run. Everything was running inside my local space. But I can also use this Thai to deploy to Kubernetes. And for that, what you need to do is basically go execute another command, which is Thai deploy -i. Zoom in a little bit. Yeah, this is the code. If you just start running it, it'll ask you a few details. You just have to run those details, and it is going to deploy to your Kubernetes. So in my case, I have this deploy. So you can see kubectl get pods. So there you go. So these are all things, front end, back end, everything code that I showed you right now, it's all running in Kubernetes. Now I can go and hit this Kubernetes port, and I can show you this thing is working in Kubernetes. Now, a few tips for someone who has worked with Docker for so long now. So a few tips is like, whenever you're working with Docker, you try using WSL2. This is the thing, use WSL2 engine. This makes much easier for you to run it, because otherwise you will have to provide a VM with configuration like you want 4 GB RAM, 6 GB RAM, 8 GB RAM. None of these things is important anymore when the WSL2 base engine is working, when you enable that, because it'll takes your machine resources and allocates resources accordingly. And you also use Kubernetes that comes with the Docker. That should be good enough. I know some of you are very you want to be very particular going with Minikube and that kind of things. That's up to you, but I just use it, and it's been working very well for me. Otherwise, I use the Azure one, AKS. So yeah, so that's for now. I only have 2 minutes, I think. So let's pop in some questions here, and I can answer that. Shiva, you're muted, I think.
Yeah, I was on mute. That was a great session, Nish. I think we don't have much questions. Okay. Okay. There are two questions. Okay. Two are from Anshuman. Okay.
This one?
Yeah.
So if Redis is known for in-memory cache, then why do we need different service for Redis? As in YAML file, you pull new Redis image for creating a Redis. So, I just showed it as an example. That's it. I was not using. You can use in-memory cache if you want to, but Redis, you can use anything. Like I just wanted to show you as a data store, and Redis is often used for in a lot of production scenarios too for caching, because it's really really fast. And we do that with eShop and containers too. For cats, the basket service, we use Redis cache, and it just pulls things really really fast.
Okay, there was one more question.
Yeah, how to handle the messaging communication between microservices at failure time? Can we create multiple instance messaging system like service bus queues, or can we scale out and scale? Yeah, so I think for resiliency, instead of explaining this whole thing here, what I would suggest is go to, because we have all these things documented, go to architecture. In eShop and containers, both the books actually covers resiliencies in detail. So I would encourage you to take that. I think, yeah, here you go. So implementing partial failures, strategies for handling partial failures. You can actually go and look at this. One is code-based implementation, which is the poly that we talked about. The other is probably looking at something like a service mesh to do that for you, right? So that is also available to you, which as a sample here, GitHub on .NET. Yeah, just go check these out for handling resiliencies and other things. And the other, if you're using like managed services like Service Bus, Azure Service Bus and other things, make use of the resiliency factors that come in with the services. They give you certain resiliency options there, so play with those configurations too.
I hope those answers well, Anshuman. There was one more question from Manik.
Okay. Yeah. Often org stress on quality and security to be considered in the design and implementation of research and suggestions on TDD for microservices and on securing microservices. Yes, there is a whole thing called SecOps, security ops, which is something which is talked in detail again in Cloud Native book. Go check that out. Security is an important aspect for sure, and that is why a lot of times we actually encourage, if you're using cloud-based deployments for microservices and other things, we encourage you to use these managed services because they come with these secured options available. There are other things like, okay, one of the things that I forgot to show you this is basically going to aka.ms -microservices, which is, if you're just getting started hands-on with microservices, there are a bunch of concepts there which you can actually get started with. So these are things. So someone asked you about resiliency. There's a whole module about it, which is like, hands-on. And why I brought you here right now was basically, there is something called as things like feature flags and configuration key vault, and I think Azure key vaults that you can use for securing some of your keys and that kind of thing. So there are a few things that we explain that in this module called feature flags as well. So this feature flag is nothing but like when you're in production, you actually toggle switch for features and other things, but it also talks about a few things with configurations and key vault that I wanted to tell you about. Yeah. Yes. And you need to secure applications, and that should be your first choice when you start with microservices. And I'll tell you another challenge that we face is having HTTPS enabled. The challenge with HTTPS is when you are actually getting started and trying to learn things, we can do HTTPS with Dockers and AKS and things. The problem is it makes it extremely difficult because you need to have Let's Encrypt or some other certificate generated and do all those things. So before you even start to learn it, it makes it extremely complex to go through these steps to get to the product, the thing that we are trying to explain. So that's why we try and avoid those discussions, but it does not mean that, you shouldn't be securing application. So you should be doing securing application. There are a few things like, when you can actually secure your API gateways, because that's the entry point. You can have TLS termination. If you use API gateways like Azure application gateways or Azure API management or things, they all provide you with TLS termination. So you can have those TLS terminated at the gateway and have a faster communication in HTTP under the hood and things. So there are a few other things that you can do.
Okay, I hope that answers well, Manik. Nish, I had a question for you. So
Sure.
it's more like, while making microservices is basically a pattern, right? But people often consider that, you need to use Docker, you need to use Kubernetes, and you also introduce about TIE. I had
Yeah.
this question while working with Azure Functions. The pattern remains same, right? Everything is quite modular. Like,
Mhm.
the business is limited to a particular function, and everyone has their different work. Nobody gets, what do you say, interlinked, and they can deploy them simultaneously, and the
Mhm.
impact remains to that particular function itself. So do we call that microservice as well, without using
Um,
anything like Docker or Kubernetes?
Yeah, absolutely. See, as I mentioned earlier, microservices architecture is just a design pattern. As long as it actually splits the business, boundaries, you specify business boundary, and individual teams are able to ship applications independently, like without breaking another system. That is microservices architecture, right? But don't confuse the Docker and Kubernetes with microservices, because that's what I initially said. Like, if sometimes modernizing something means you can take a monolith application, containerize it, run on AKS. That doesn't mean it's microservice. Microservice comes into play when you are talking about independently scaling applications, independently deploying, and they are defined by a certain business boundary. And it comes from the distributed architecture world, right? So those principles and all kind of things, like cap theorem, about how you can keep the data. So yeah, those kind of things have to be taken care of. That's why they define this as a design pattern. That's what it is. So Docker and Kubernetes does not mean it's a microservice. It's just an endpoint you start with. That's it.
Okay, Nishvi has some amazing questions, and you had shared a lot of resources. So I would like to pick one question,
Mhm.
which you found to be quite interesting, so that we can offer them an ebook
Yeah.
from a sponsor.
Oh, you want me to pick one question from I think
Yeah.
the security based question itself, we can pick that up, because it's an important aspect that I did not mention. And thanks, Manik. I think Manik A.
Okay, that's great. So Manik, please mention your email ID in the comment section so that we can reach out to you. Thank you, Nish. Thank you for an amazing session, and we hope to onboard you in our future events. Thank you.
Thank you so much. Thank you for having me.
Okay, everyone. So let's get started for the next session. So it's on building browser-based apps with Blazor, and I'm going to do that. So let's get started. Okay, let's share my screen. Okay, perfect. I hope it's visible. Perfect. Okay, so let's get started. Building browser-based apps with Blazor, and I'm going to give it. So just a small, what we say, introduction to myself. So I work as an associate software developer. I'm a C# Corner MVP and a cloud enthusiast. I work, my primary role is to work as an ASP.NET developer, and I also work on the RPS side. I'm a certified UiPath developer, and you can reach me out. These are the addresses which you can use. I'm quite active on LinkedIn and Twitter, so if you want to talk anything about my session, you can reach me out, post this. We can have a discussion then. So let's get started with the agenda of the talk. So the agenda is something like this. How we will start with how the web development environment is right now. What is Blazor? Then what's WebAssembly? Then Blazor server versus Blazor basm. Then a demo on component routing and debugging in Blazor. And finally, we'll close the session by deploying our application to the cloud. So let's get started. So typically what happens is nowadays is that, not nowadays, how application are actually built. We have an API, we have some, we use some UI frameworks or to build our spas to, so the presentation layer or the UI layer. So typically, so we normally use .NET Core Web APIs to build the backend. Or if you're a Python developer, you can use Django REST framework, or else if you're a Java developer, you use Spring or something like that. And you just find the endpoints in your Angular application, or else your Vue.js or React application, to show the whole UI in a beautified way, and it's really good. People have embraced it well. Organizations are using it really well to build literally all kind of applications. So, but there is one constraint, like, see, when you're making a web API, you're using .NET Core. So at the core of it, you're using .NET Code over there. You're using C# to write your code. But when you're trying to write the UI part of that, suppose you want to go for a full stack role and you want to be a full stack developer, build the UI as build the front end as well as the back end, you need to know JavaScript for that. And not just JavaScript, you need to be good enough in UI framework like Angular or Vue or React. There are a lot many frameworks that are available out there. So you need to be good in that. So it's normally quite troublesome because you have already invested a lot of time getting acquainted with the whole .NET ecosystem or else with the Django ecosystem, building applications with that. And to make the front end now, you again to reskill yourself in a different framework. And these frameworks are evolving really fast. I don't say it's wrong, but coping up with that is pretty difficult. So as a .NET developer, you can still make web applications using Resiliency with ASP.NET MVC. You can do that, but you cannot make a SPA with that, right? So you had to use Angular applications back then. But with Blazor, we solved this problem. So how the word Blazor came from? It's just like browser plus Razor is Blazor. It's like C# on the browser. So we are going to leverage the power of Razor syntaxes to build SPA applications using C#. So what's Blazor? So Blazor is a component-based UI framework which lets you build web UIs using C#, HTML, CSS, instead of JavaScript with the help of WebAssembly. Though it's not completely true because that you might already have an application which has a lot of JavaScript code written in that, and there are a lot many things which we cannot do right now with Blazor. Which we can do with JavaScript. So what we can do is that we can leverage the power of JavaScript in our Blazor application by using an JS interop. We do have the capability to do it. So this is what Blazor is, and Blazor takes the best of all the frameworks out there because it came way later after Angular, React, or Vue, or any of those frameworks. So it gets the best of all of them. It tries to get all the best features from them and make it. So what is WebAssembly? So this is something I got from Mozilla's documentation. Like WebAssembly is a new type of code that can be run in modern web browsers. It's a low-level assembly language. Let's skip the description for the time being, and let's discuss in a simple way. What is WebAssembly? WebAssembly is something that enables us to write write code which can run on the browser with any language, which can convert its code into a WASM format. So WASM is again more like the bytecode for the web browser. So what happens is that if you have your compiler which can be converted into a WASM form, and then it can compile back those code into the native code which your browser can again understand, you can absolutely do that. So you can use languages like C, C++, Rust, C#, Python, or anything. If you have a WASM for that, if you have a WebAssembly which can compile that again to a native file, you can do that. So this thing came up in 2015 when all the major vendors, browser vendors, came up with this thing that we need to have a unified way to give an access to this. So this is more about WebAssembly. So WebAssembly is the thing which enables us to write .NET code in the browser. So there are two hosting models basically available for building Blazor applications. There are other, but those are experimental till now, I guess. So we have two things. One is Blazor Server, and the other is Blazor WebAssembly, which we also call as Blazor WASM. So how does Blazor Server works? So this diagram can give you a rough view, rough idea how a Blazor Server application actually works. What it does is that all your business logic, everything is actually run on a server, just like how it works in an ASP.NET Core web application. So what happens is that when you're making a request to your URL, to the URL of your website, it takes back all a blazor.js file, which sets up all the signal connection, prepares the rendering tree. But the rendering tree is actually is maintained on the server. So any changes or any UI event that is happening is modified in the render tree, and that particular change is transferred back to the server using signal or sockets. And every time a change is happening, you get a response using the signal connection. So it's quite stateful. It's a good way to do it. This is how the Blazor Server application internally works. So what are the advantages? Why should I use Blazor Server? So these are a few advantages of Blazor Server. One is the application loads much faster, can take full advantage of the server capabilities. Like you can use all the capabilities that your ASP.NET Core application can use in an can use while deploying it into a server. So all the client needs is in browser to use the app. You're not dependent on the capabilities of your browser or the hardware capability of the device that the user is using. So these are more secure as the app code is not sent to the client. You're not exposing any of your code to the users. All the code stays in the server, and so it's quite secure. But it also has some drawbacks. So what are the drawbacks? So one of the drawback is an ASP.NET Core server is required. You either need IIS or else something like a Kestrel or something like that to deploy your application. And active internet connection to the server is required. If you don't have an internet connection, your application is not going to work. It's more like all your code is not being saved on the browser, right? You're not storing it in the cache that you can work around, you can play around with that. You cannot do that. So this is one drawback that you have. If you don't have the internet connection, the complete application just crashes. You cannot work with that. So high latency due to your round trip, because every time an UI event happens, the render tree modifies. A round trip happens. One request is sent to the server through the signal or connection, then the updates come in, and those are reflected in the screen again. So a complete round trip happens to the server. So the scalability aspect can be a challenge, because there are so many because you'll be having so many signal or connections established over there. You can face a problem with that, but you can obviously use Azure Signal R service to tackle that. So that is one way to do it. So what is Blazor WASM? So earlier we discussed that Blazor server has a disadvantage that without internet connection it's not going to work. But typically, if you see when we are making some application with JavaScript, have to add some dynamic functionality to our page, we don't need an internet connection, to be honest. The JavaScript code is there. You just have your logic on the page itself, and whatever you write over there, you can do that without an active internet connection. So Blazor WASM helps you get that. What it does is that it downloads an WebAssembly, .NET WebAssembly, which along with all the DLL files or the .NET code of your project, it gets everything to the browser. It compiles them. This .NET.wasm, what it does is that it compiles the whole DLLs, all your business code into a native format, which your browser can in turn understand, maintain a render tree, and every changes that you make is reflected in the DOM simultaneously without the need of an active internet connection, unless you are accessing an API to modify those things, right? You're dependent on an API to get the data or to update the data or do something like that. You need not be worried. Any functionality which can be done within the scope of a browser without an internet connection can be done by this. So what are the advantages of Blazor WASM? So an active server connection is not required, as we had discussed just before. The client resources and capabilities are used. You use your client's devices capability to the optimal level. But the problem is, if your client doesn't have a good enough device and you have made a resource-intensive application, the application can go on for a toss. Full-blown ASP.NET Core web server is not required. You can you can go for a static hosting option. You don't need a dedicated server for that, so it indeed saves your cost. Can be hosted in your own server, cloud, or CDN. You can deploy this WASM project in a content delivery network like an Azure CDN, or else in your own server, or else in a cloud. Like if you're going for an ASP.NET Core web hosted model, then you can also deploy it in an Azure App Service. Or else even you can do the same over in AWS. No issues with that. So what are the disadvantages? Like every good thing, it also has some drawback. The very first request, I'm sorry for the error. The very first request usually takes longer. Now, before I told you that Blazor server applications are really fast because all the things happen usually on the server side. So your server is really good enough to handle a lot many requests and do all the processing by its own. But what happens with Blazor WASM is that it downloads all your DLLs, then it also downloads at runtime to process those DLLs and convert into a native code. So the first request is normally a bit longer, but we can work with that, right? So it is restricted to the capabilities of the browser. So this is a drawback that we have, because we're doing everything on the client's device. We are not making a lot of changes. But if a resource intensive task is there, if we can do that in the server, and if we have an API doing that, then we can also do that to reduce the pressure on our application, on the WASM application. Capable client hardware and software is required. As I told you that in 2015, all the major vendors came up with the concept of this WASM and everything. So all the browsers which are coming after 2015 supports WASM, so your Blazor WASM application can work on them. But if you're targeting something like a legacy browser, like an Internet Explorer or something like that, it's better to go with a Blazor server than a Blazor WASM, because it's not supported over there. So you can go with Blazor server and work on that. So let's have a look at a sample Blazor server project. So what I'll do is that let's create a Blazor server project. So I'm using Visual Studio 2019. So you can use VS Code too. It's just that I prefer Visual Studio. Okay, so I have a few templates over there. So right now I need to select the template for the Blazor apps. It's taking slightly longer. Okay, we got it here. You need to select Blazor app over here. So let's give it a name. App.demo. Now you'll see an option to select whether you want to build an Blazor server application, or else you want to select an Blazor WebAssembly app. So there are two options available over here. So you can see that ASP.NET Core hosted and progressive web application. So if you want to deploy it on an app service kind of a thing, you can click on that and do it. Or else if you want to make a progressive web application, which you can absolutely do with Blazor WASM, you can select the progressive web application, make one. But for this demo, we are gonna look at the Blazor server app. So we can take it. Let's click on create. It's going to create a project. Then we can have a look and feel about the whole file structure and everything. It takes some time. Please bear with me. Okay, perfect. It's gonna take some time to load all the dependencies. So anyway, click on run and see how the whole thing looks. Okay, it's taking a slightly longer than usual. Meanwhile, what I can do is that I can show you some of the file structure over there. So you can see that we have a startup.js and program.cs. Sorry, startup.cs and program.cs. If you have worked with an .NET Core application, .NET Core web application, then you must be aware of this. So you're creating a host. Okay, it seems like our application has just started. Okay, let's look at the application, the demo application which Visual Studio gives us by default. This is a default project template that you get with this. We'll make some changes with it and explore what are components and how to do routing in this and how to debug and Blazor server application. Okay, so this is a simple, simple project that we get by default. So there is a fetch data. It is using dependency injection to fetch data about the temperature. And there's this counter which works like this. Okay, so let's close it and look at the file structure over here in the Solution Explorer. You can see that there's a program.cs, that's a startup.cs. So the program.cs creates a host builder. Then it configures all the startup objects. What happens in the startup is that you configure your middlewares and your services. If you want to do dependency injection, you do it in the configure service, and you can manage the middleware pipeline over here in the configure method. So as you can see that, as I told you, that we use what we say, signal connection. The map Blazor hub handles that for us, and probably here you can see that we are using dependency injection. We are using our singleton over here for the weather forecast service. So let's see where the services are. So let's go to the data, and here you can see that I have weather forecast model, and I have this service. So this is what generates the whole data for us. So this was for the weather forecast part, and let's see now what is app.razor. Okay, before going into app.razor, let's go to the let's select. Okay, no issues. Just give me a while. Okay, you saw a hello world kind of a thing over there. So this is a component over here. This component, shows us this whole thing. So I'm looking for our main layout. Okay, this is the main layout. Here we have multiple components, as you can see. One is the nav menu. Then we have this body. Inside the body, all other components are being rendered. So that is being done in the app part. Okay. So here we have another thing called the part section that was in the top header over there in our page. So what I'll do is that in the fetch part, I'll just go over here, attach a breakpoint. Okay. I'm having some issues. Okay, let's go to the counter then. Sorry for that. I'm having some issue right now, which I'm. Okay, for the counter one, you saw that, when I clicked on the button, click me, the count automatically used to go up. So how can we debug this application? Let's click over here to enable a breakpoint, and let's start it over again. And see, can we debug our Blazor server application? It's just starting our application now. Just click on Shift I to see what are the things that are being loaded. Okay, you can see that a lot of files have loaded over here. There's a bootstrap.mean.cs, there's a site.css, then there's blazor.server.js. This file is, what establishes the whole signal connection and prepares a render tree and everything. So this is that one. So let's click over here, go to the counter, and check. Every time I click on this particular button, it goes to the breakpoint, and the value of our count increases, as you can see right now. Okay, I can see the value of current count. It go to 1. Just click on continue and go back. And it's done. Let's remove the breakpoint and see the changes over there, over here in real time. Can we see some changes? Okay. We are unable to see them. Okay, fine. Okay, so this is how a Blazor server project is. It looks like, and there are multiple components over here that you can see. So this is the host.cshtml. So here you can see that we have an environment. Okay, let's not bother about the environment included. In the component type, you have app. So what is this app? This app is again an Razor component in which is responsible for the routing of our Blazor server application. So what it does is that if it founds the route, if it founds a matching route, then it routes to that particular component. If it doesn't, then it is gonna show you, sorry, there's nothing at this address. So let's create a new component over here. Let's create a new Razor component. I'll call it display data. So, okay, so I'm not going to do anything, too exciting over here. I'm just going to type in hi. Welcome to .NET Conf. Finisher. Okay, fine. So as you can see that I have created a component, but there is no way to how we can go to this particular component, how to route this. You can see that there is a directive called page over here, and we have something called /counter. So what happens is that this directive tells, like, if this particular thing comes in the route, you need to go to this component. If this comes, then you need to go to something else. So to do that, let's create a page with a slash, then I'll try display data. Let's click on save. Let's start this. Let's start our server again and see what we get on display data now. As I told you before, everything in a Blazor application is more like component. You can have multiple components in a single screen. You can nest components. A single component can have child components also. There are a lot many things. I'm going to show you how, okay, I'm going to show you how we can do that. So here you can see there is no way to go there to go to the new component that we made, but we can do that using the route. In the okay, in the counter one, you can show the route change over here to counter. So instead of counter, let's keep it as okay. Let's keep it as display data, and we'll see that we are being redirected to different component, or we can see the data that we wrote over there. So this is how easy it is to create a component. Let's stop the server again, and I have some boilerplate code ready with me. So it's to make an what we say. Calculator kind of an application. Okay. So let's add the HTML part over here. Okay. Okay, so we are seeing those swigglies because we haven't declared the variable as of now. So that's why we are seeing those red swigglies over there. Once we had pasted all this section inside of a code part, you see that all those things went away. So what is this @code? If you people have ever used web forms, made the application using ASP.NET web forms, then you might be aware of something called code behind files. We used to write all our codes and the code behind files to process the whole thing. So it's pretty similar to that. What I did is that I declared 3 variables. One is num1, num2, and I have total. So I have few what we say text boxes over here. So I'm binding them. So @bind, what it does is that it binds the value that you type in the text box to the variable that is over here. Okay. So you can do that, and after that, you're getting the value from both these text boxes, like one for this one and the other for this one. So you get the data for these 2 text boxes. So you created some buttons. We have some buttons like one for add, one for subtract, one for multiply, one for divide. So many buttons are there. So normally, if you wanted to do it in JavaScript, you just use the onClick attribute and just enter the method name, and you do that. So similarly in Blazor, what you do is that you just define the method name over here. Like I did it over here. I have few methods here, like sum, there's one for difference, there's one for product, then one for divide. Okay, so you can do that by using this. Let's see what we get over here again. Start the server and see what all we see. Okay, let's go to display data again and see whether the changes are reflected over there. Yes, the changes are reflected. Yeah, seeing good enough UI. Let's click on add. Okay, so let's click on subtract. Okay, perfect. So you can see that during the division part, I had handled the exception. Normally you get an arithmetic exception if you divide something by 0. So let's do one thing and click on 0. Click on divide. The total becomes 0. We shouldn't, I should ideally show a message or something like that, but I managed to handle the exception. It didn't crash. My application didn't crash. So it is very similar to the way how you do exception handling in your normal .NET application. You can use your try catch block to handle that. So this is one way to do it. So let's do one thing. Okay, once you can see that I wrote everything inside this code file, right? But when you are working on a large application, working with this can be a bit scary, right? You are writing so many lines of code, and you need to handle the UI as well as the code for this in a single place. It is pretty difficult, right? So what we can do is that we can create a partial class to do this. We can create a new class for this with the same name as that of the razor component. Display data and partial over there. Okay, sorry for this. What I can do is that I can copy all this code from the @code directive and paste it over there. Okay, so let's start. Okay, I didn't stop my server while I was making the changes. Okay, so let's run it and see whether our application is working as it was expected to work or not. Let's see this. Okay, it's taking a bit longer. Please bear with me. It typically doesn't take so long, but things happen. So yeah, you can see it over here. Let's add a few things. Come add. You can see it works absolutely well. How it should work. So this is how you bind. What do we say? How you bind values. How one-way binding happens in Blazor. And that was about components. Now, can I nest this component inside another component? Like, yes. If you look at the index.razor component, there's a survey prompt title. So there's a survey component that's there, which we are actually, what we say, are putting inside another component, nesting inside another component to be precise. So we can also do the same with our display data. What we can do is that this call on display data. It doesn't take any attributes, so you can just end it like this, or else, okay, let's keep it like this and see what it does. Whether we see our display data, component inside our index page right now or not. Earlier we used to, go to that particular route with display data to see the component, but right now we should see it in the index page itself. So we should be able to see that. Yes, you are able to see that right now. See, let's check the functionality. It works well. So this was all about components and data binding in Azure. So let's, since we have some time, let's see how routing happens. So to work with the route, you can give anything like author or data to specify the route and the page directive. And if you wanted to pass in a value in the route itself, like I'm doing right now, what you can do is that let's give it a name. Let's give it something like name. I'll have an code block over here. What I'll do is that I'll create a property pretty quickly. Sorry. I'll keep it a string. Then I'll keep the name same as the name that I've given in the, what we say, route. That's the name. So right now it's not going to get it, but if I add an attribute over here called parameter, it's going to fetch the value from value that is passed in the route called name and display it over here. To display it, what I'm going to do is that I'm going to do a simple paragraph tag and write a name. This is very similar to the way you do with razor syntaxes in our normal .NET Core applications. So let's see if we pass in a value. Okay, if we pass in a value something like name, do we get that? Okay, now we are going to see some unexpected things over here because I changed the route and it doesn't have any other route. The index component doesn't have any route, so we're going to see an error. So sorry, there's nothing at this address, but if I type in /data /Ashirwad, you're going to see the index component right now. So this is how it looks. Okay, so what happened actually, and you can also see that my name is also displayed over here. So let's see what happened over there. Why didn't we see anything in the index part, in the starter when the index page showed up? Why it didn't show anything? What it does is that it is expecting that you are going to pass a particular route over here. So if you keep it as question mark and add another way of using this, what it's going to do is that you're giving multiple routes for this. Okay, there was some error. Okay, now it should work. Okay, so now you're saying that the name parameter is optional and you have two routes, right? You can go to the index page by just clicking on the localhost part or else your website, you're going to land on that. Apart from that, you can what can also happen is that whenever you pass in a value, something like this, like you given /data/name, you also get that. Okay, right now you don't see my name because it's optional. Now, if I go to data/.NET, you'll see .NET over there. So this is how you pass values using your route. So let's deploy our application in Azure. Since we have less time, let's deploy it and see. Okay. So let's click on Azure. I'm wrapping up things quickly because we have some Q&A session after that, and we have very less number of time over there. I'm selecting App Service for Windows. So you need to be signed in your Visual Studio with, with an account which has an active Azure subscription. So, okay. I don't have any, app service there to deploy my application. So I'm going to just quickly create one over here. Great, perfect. So it's going to take some time, like 30 odd seconds to create an app service, spin it up for me, and where I can deploy my application. So I'm just creating that. It's going to take some time. Please bear with me. Okay, it did create. You can see that there are slots also available, but since we haven't created anything, I'm unable to see it. So let's click on Phoenix. It should create a profile. Okay, our profile is ready. So let's click on publish. Okay, it's recommended because since we are using Blazor server, but for a Blazor WebAssembly application which is hosted on an ASP.NET Core server, it's not required. Even right now, we don't need it because we are not going to have a lot many users using this applications, right? It's for demo purposes, so we're going to deploy it over there. Once it's done, I'll share this link over in the comment section where you people can go and check it out. So this is how easy it is to deploy your Blazor server application to Azure. It's pretty much similar how you deploy an .NET Core Web API or an ASP.NET Core Web application to Azure. So it's going to publish it, and it's taking some time. Okay, so let's wait a bit. Okay, in the meanwhile, we can have some questions because we are already running out of time. Okay, the build started. It's being deployed. What I'll do is that I'll copy this. Okay. It's not allowing me to copy that too. Let's wait for a while. Okay, started publishing our application. Okay, it's gonna take just a few more minutes. Okay, it successfully deployed our application, and it also showed us over here. Okay, let's see our application live and running. If it works well or not. Okay, you can see the application over here. So let's see if the route works. Data/Ashirwad. You can see that Ashirwad is still being visible there, and let's see if all our functionalities are working as well. Yeah, it does. So that's all from my end. Thank you, people, for joining in. Let's have some questions. Okay, do we have some questions? Okay. I guess we don't have any more questions. So let's wait a while since we still have some time. Let's see if we do have some questions or not. Okay. One thing we can do is that we can take a 5 minutes break because we have been going on since last 2 hours 40 minutes odd. So let's have a 5 minutes break and catch up around 4:50. Into that, people. Hi, Gabriel. This is Ashirwad here. Hope you're doing well. Gabriel, can you hear me now? Okay, I'm unable to hear you, so.
Hello, can you hear me right
yeah,
now?
I can hear you. Yeah.
I cannot hear you. I am sorry.
Okay.
Uh,
Just give me a moment. Just give me a moment.
well, just confirm me that that you can hear me. But it would be nice to say hi to Ashward. Hi, Ashward.
Hi, Gabriel. I can hear you.
Unfortunately, I'm not listening to you.
No issues. We can start off your session.
Well, anyway, if you can hear me, I want to thank Ashward and say hello for everybody from Bhubaneswar. To me, it's a great pleasure to be here, and I want to thank you for the invitation. Let's discuss a little bit about .NET and software architecture. That is always a pleasure for me. The session that I will present uh, uh, is related to serverless architecture with .NET 5. And I always try to bring to my sessions the importance of thinking about production environments, right? And that's why we're discussing here how to achieve scalable and secure solutions, right? I'm Gabriel Baptista. This is my email address where you can find me. And I always try to present to people that doesn't know me some good information about myself. So who am I? I'm a software architect for more than 10 years with more than 20 years developing solutions for the retail and industry market. And I'm also a researcher for more than 15 years trying to develop software with good quality, right? And for the last 10 years, more than 10 years, I've been teaching for colleges related to computer engineering here in Brazil, where I stay. And to tell you the truth, I do love this this career. And thanks to this career, I was able to write this book together with Francesco and with the help of Pact, where we discuss a lot about software architecture using C# and .NET 5. So the question that I want to discuss here, the first question that I want to discuss here is, hold on, let me see here. The question that I want to discuss here exactly is, why are we here? Why why in a Sunday afternoon for you, uh, uh, morning for me? Why are we here? And I just collected some of the words that you have in this wonderful event that Ashwar has promoted. And wow, we have Azure functions, we have APIs, we have messaging brokers, we have clean architecture, we have Blazor, microservices, scalability, Kafka, Xamarin. Wow, that's the reason we are here. I don't think so. This is not exactly the reason why we are here. The real reason why we are here is that the fastest you build the solution, the better. That's the key point. That's the key point for soft for us. Uh, Today, we do need to develop good solutions in a really fast way. right? And for this reason, uh, we cannot forget these key points that we commonly call non-function requirements, right? We call them that requirements where the user he doesn't see these requirements working, but at the same time, without them, you're not going to have a good solution. Yeah, and considering this scenario, we do have many good options. Microsoft has brought to us many good options, right? And I really love this picture because it shows exactly what the alternatives that we have nowadays, right? The the first alternative that we have is to deploy all our solution on premises, where you need to manage everything. Since the beginning of the cloud, we started having the opportunity to deliver software using the infrastructure of the provider. And in this case, you have infrastructure as a service. Then, more recently, but not too close from now, it's been here for some years. We have the option of platform as a service, right? And this was incredible, right? I do love platform as a service because it enables us to deliver really fast solutions. These solutions in general can be served as a software as a service, right? So many guys that are watching us today are developing software as a service solutions, right? Or intend to develop software as a service solutions. But to do this in the velocity that the market needs, we want to think, we need to change the way we develop, right? We want to change the way we deliver. And in some cases, you may consider serverless architecture, right? A serverless architecture is a solution where the focus is not on where the code runs. This is really important, right? What is serverless? We don't have serverless. We don't have a server in a serverless solution. Of course, we do, but on the other hand, you don't need to worry about where the code runs. That's the key point, right? You don't have to worry about the infrastructure itself. You just need to worry about your code, and this is good. This is good, but in not all the cases. So there are some cases where this alternative can be used, right? The first one that I want to consider is when your team is focused on coding. I mean, you don't have a really big infrastructure team, or you are, or you don't have an infrastructure team, but you have developers. In this scenario, serverless would be a really good option because if you consider using developers for uh, setting up an infrastructure as a service or even servers on premises, maybe you're going to have some trouble, right? Uh, there's another really important thing that I would consider to decide using serverless. The first one is that you need to think about a quite simple solution, like a microservice solution, right? And most of cases, it's an event-driven development. I mean, you have events that uh, can make you can enable you to make things work without without simple simple screens where you include or update or delete data, right? There's another scenario where microservices, sorry, where serverless solutions would be nice is when you need background processing in the cloud, right? So you can use this serverless scenario to develop background processing. Well, anyway, okay. I do have a scenario like that. So you can use Azure Functions, right? So I'm here to present to you not only the Azure Functions, but how Azure Functions can help you with that, right? And Azure Functions, just to let you know, is a PaaS platform that delivers event-driven, serverless, and scalable technology to accelerate our project development, right? So basically, it's a PaaS platform that will help you a lot develop serverless solutions. And in this scenario, right, you need to understand that developing for cloud always is a matter of how much you pay and how you're going to use this, right? And nowadays, there are three plans in Azure Functions, right? The first one is consumption, the second is premium, and the third one is dedicated. You can check it out. You can check the details of these plans in a website that I just mentioned here, and then I will give you the PowerPoint so you can. I will share this presentation so you can check the links later. But if we compare consumption versus premium versus dedicated, the key point here is that when you start using consumption plan, you just pay for what you use. While when you have a dedicated plan, you need, or even a premium one, you need to start paying without using, right? Oh, but I don't want this. But sometimes you have, for example, an app service that you can share the price, the money that you are spending, and maybe it would be a good option. There are other reasons why you can exchange between consumption, premium, and dedicated. I would say that one that is really important is the timeout that is guaranteed by each execution, right? If you think about consumption plan, you only have 10-minute timeout for an execution of a function, while in a premium service, you can get up to 60 minutes, and in a dedicated one, it's unbounded. So depending on the development that you are doing, depending on the solution you are developing, you may exchange between these three plans, right? On the other hand, we have really good possibilities in Azure Functions, right? Nowadays, in the version 3, we have type triggers, we have queue trigger, you have HTTP trigger. Each of these triggers can help us out in developing a solution where you're not going to see exactly the server, right? That's the point. That would be nice, right? And okay, we got it. I'm here. We're talking. We have a really briefing about Azure Functions. We understood that Azure Functions can help you develop serverless architecture. Good. That's nice. Great. Let's create it, right? And let's create with the really new version of .NET. That's not .NET 5, and then the things start getting difficult. Let me show you that. Well, when I try to create in Azure Portal a function app, as you can see here, I can assign, for example, the resource group. I can assign the instance name, and I want to define runtime stack. And oops, there is no .NET 5. What do you mean by there's no .NET 5? And yeah, there's no .NET 5, not yet. If you take a look at these posts from last December, the reason why Microsoft is not enabling .NET 5 support on Azure Functions right now is because .NET 5, it's not a long-term version support, right? And then, oh man, so what does it mean? This means that when you, for instance, develop a function using .NET Core 3.1, you just release it and it works fine. However, if you just extend here, as we understood as the recommendation for the first recommendation, right, for updating our solutions to the new framework. Believe me, this is written in Portuguese, but it's not a good answer for my web API here. So thinking about that, I want to show you a really scenario that Microsoft team, especially Azure Function team, is working to help you out with that, right? This is .NET 5 Worker, right? This is pretty new, right? It will be generally available only this year, right? And to tell the truth, the first release of version 1.0 was the one that I tried to use here to present to you. And unfortunately, it's really new, right? For instance, if you check just time trigger support, it's not working yet, right? I just it was 2 days ago, as I believe. I just sent a message to them saying, "Hey, it's not working, not yet," right? But for HTTP trigger, it's working, right? The startup of the function is quite different, and I will just move to my .NET here. I will share this code for you, right? But this is the solution, right? We basically have .NET 5 running here, and we need to add these packages, these preview packages of Azure Functions Worker, right? There's another really important thing. You cannot debug this code using Visual Studio, not yet, right? And if I want to just run it, let me get here in command line. Here we go. Okay. Great. Let's just start. I'm not sure if it's going to check this. No. Hold a second. Okay. Yeah. My Windows is in Portuguese. That's why you're not understanding the messages. But basically, it's starting Azure Functions. It started the worker, right? And as you can see, time trigger is not working properly. On the other hand, if I try to use this here, let me go here. Yeah, it works, right? So I believe this is going to be one of the options for using .NET 5 in Azure function environment, right? But it's pretty new, really new. So I would say to you right now that this is not for production. This is definitely not for production, right? I will share this code with you, so don't worry about that. And you can follow their GitHub, where you will find the messages and the issues that they have. So don't worry about that, right? So I'm not really happy about this scenario. And here we have to remember that .NET the .NET team basically defined that in general, we're gonna have we're gonna have long-term support versions every even year, right? So we need to pay attention to this, especially if you are deploying a solution to a customer, right? This is something that we do have to worry about. So some good advice: before migrating your solution to .NET 5 or any other that is not long-term support, consider all scenarios you have. Like other projects, consider the main class of your function as a trigger for your business rules class. What I mean here is that maybe you need to think about uh, your your Azure function as just the trigger for a business rule layer, right? This is going to be useful because the Azure function startup method is a little bit different from this new library that they have provided. So maybe you're going to have two options, but you need to keep up with the same business rule, right? Understand the kind of software you're developing and the time to market of your solution. That's why Microsoft and other players define preview release candidate generally available and long-term support. In my opinion, you just need you just have to put a software in production when it's long-term support, right? Well, considering that we are not going to have Azure function running in production using .NET 5, let's go back to .NET Core 3.1, right? And understand how this can help us in a serverless scenario. And I have this demo here that is something similar from what we have in the book, where basically I have two Azure functions, one that's an HTTP trigger and another one that's a queue trigger, right? Receiving information from anywhere, a mobile phone, a website, a desktop application, and this information is a request to send a mail. And then I store this, this, this request in a Azure queue storage that will trigger the function that will really send the email, right? And I'm using here Office 365 Outlook, so I can just have the email sent, right? Let's check it working. Oh, so for doing so, I will show you a Postman. Hold on a second. Here we go. And there's something really important. As you can see, I'm just sending this to the Azure function already deployed, right? And it took a little. This behavior of taking a little to start is what we call cold start. Why? Because I'm using right now the consumption plan, the serverless solution. So it takes a while. If there is no message received, the servers inside, they stop, right? And after that, when you have a call, then you're gonna have a fast answer, right? Right now, I just sent many requests, right, of this email. It's just a basic solution, right? The basic test. And as you can see here, I'm gonna receive this in my mail, right? Good. Oh, but you can use the API to solve it. But what if the email server is not working, or it takes a long for this server to work, or even you want to send alerts not only for email, you want to send alerts using SMS or another messaging solution. So this could be nice. And basically, if you check this solution out, what we have here is an API, right? That where we post a request, and this request just is sent to a cloud queue, right? This cloud queue basically is here. It's a storage queue, right? As you can check, let me send some. For each sent, you see, it refreshes, right? And as soon as this API send the data to the email queue, oh, the queue is processed by another API, another function, sorry, this one, right? Where basically I am sending an email. And there are some tips here that I want to share with you, right? The first tip is we do not have here any uh, uh, any sensitive data stored in the code. Why? Because I'm using here the environment variables that Azure Functions provide, right? This is a really important point because, as I told you, we want to develop solutions that are fast to deliver, but at the same time, they need to be safe solutions, right? So this is a very good. Oh, this is the code that I just showed you, and this is a really important aspect, right? Environment variables, app settings guarantee you do not have sensitive data right hard coded. The first two key points here: the solution can be used by any device or platform because we just have an API, right? Scalability and performance is guaranteed by default, right? Because Azure Functions deal with that, right? Depending on the plan you decide, you may have to set up the auto scale environment, but when it comes to consumption plan, it deals with you. It deals for you. So this is really cool. You don't need to worry about that, right? This is where we define the variables, right? The environment variables. This is inside the Azure function. I'm not here trying to present how to create an Azure function because I understand that you have already seen that, right? I'm just going to go a little bit deep in the options that we have here. And one that is really cool is the configuration of your environment variables, because this will help you, right, deliver. I'm not going to change the password. This is going to help you deliver. Uh, this is going to help you deliver a secure solution, right? You may also want to use some other options of storage. One that I really think it's good to mention here. Let me just get here. Sorry. Where I don't want this one. Yeah. Hold on. Oh, sure. Azure Key Vault. Azure Key Vault is an option, right, that you can check if you don't want to store your passwords inside the configurations of the Azure function, right? Another really important thing, especially for production environment, is define TLS and SSL binding. That means you need to buy a certificate that represents you, and using this certificate, you are going to be able to make people understand that you are working in a serious project, in a serious platform, right? HTTPS only is a really, really important configuration that you should set. Here is off, but by the time I just set this on, I cannot have HTTP requests anymore, right? And these HTTP requests, this HTTP request can cause damage because, as a matter of fact, you are transferring data from anywhere to your server without a certificate, without an HTTPS connection. This is unsafe, right? Custom domains will make your solution be seen by the others, be seen by the public as a solution, as a solution that is complete. I mean, nobody wants to have, to telling you the truth, oh, check this API, DNC dash functions dot Azure websites dot net dash API send mail. No, it's my website.com API and then your APIs. This is going to be fine, right? And in general, setting up things like that will show that you are working in a professional way, right? Function keys are really important. I can demonstrate this to you, right? Function keys enable you to guarantee security, right? So let me just show that. As you can see, I am sharing this code here in the post. That's why I need HTTPS, right? And it's working properly. By the time I just go to my Azure function, send a mail, and I come here in the function key and say, oh, I'm not sure if this key is working properly. I mean, I'm not sure the people that has this key. Let me renew just as a process. It's a quite simple setting, but at the same time, it guarantees you that only authorized people can have your API working. So for getting this working again, I'll just copy here and then send it. Good, right? So function keys are really important. You can define functions as anonymous. This is not a good idea, as secured by the function key or by the Azure function, right, key. So this is something that you should think about when you're deploying to production. Talking about production, it's always a good option to have separated environments, right? So you've got to think about at least 3 environments: the development environment, the quality assurance environment, and the production itself, right? When you're, I mean, if you're just studying the alternatives, okay, you just have an environment. But if you go to production, there is no way to do that without getting different environments. And now an alternative for doing so is enabling deployment slots. With deployment slots, what you have are different areas where your code is stored. I mean, you can have a really stable code in production, and you are developing a new solution in the development slot, and your quality team is analyzing the solution that you just developed and tested in a specific environment. This is pretty good. This is pretty important, right? And Azure Functions let you define this in just a few clicks. And if we're talking about production, deliver faster, and DevOps, we need to monitor, right? And each Azure function can be monitored by this screen here. Here we go. Or you can use application sites, right? I'm not going to talk about application sites because it's a wonderful tool that every developer should study a little bit, because it's really, really useful, especially for production environments, right? But with this simple monitoring, we can check that everything is working fine, right? And we have monitoring for APIs, but we have monitoring for other triggers, Azure triggers. So for instance, I got this error here, and I can understand why this error happened. You see? So even in a production environment, you can monitor your functions. And then we're just finishing here, and I want to ask you 3 questions, right? The first one, what is the operating system version of the solution that I just presented? What is the storage capacity? How much memory do I need? As you can check, there is no answer for these questions. Why don't we have answers for these questions? Because this is serverless, right? That's the great thing. This is serverless. We don't have to worry about that, right? I guess I have a question here. How to set up certificate after expiration if I'm calling the Azure function from a web API? Because if the certificate expires, the key will be regenerated. Oh, this is pretty good. Well, basically, there's no way to let me rephrase here. You can just exchange the certificate, right? Let me just show you right here. Right, you have to monitor, basically. Thank you for the question. You have to monitor the expiration time of your certificate. This is a process that you need to monitor outside Azure, right? And as soon as you just get into the date that the certificate will expire, you need to buy a new certificate, and then you can just add here this, right? It's quite simple. You just add the certificate related to the domain that you are defining for this Azure function, and you just upload the new certificate, right? It's a 5-minute step, to tell you the truth, right? I have another question here. As the functions are publicly available, any good practice to prevent any unwanted calls being made? How to secure functions? Oh, this is really a good question, Mohit. I would say that the best way to do so is to set up for each function, as I told you here, their keys. So only people that know these keys, right, will have the possibility to access these functions, right? This is a good way. You can use API gateways to solve that too, right? Just to finish my slide, Ashward, I guess there's only a single slide for wrapping up, right? Serverless solutions are faster to deliver, as you can check, right? We just built it with 2 functions and a gate and a stored queue. We developed a solution that we can send data to send emails to anyone, right? And they can guarantee at the same time performance, security, and scalability. And for that, Azure Functions is an excellent option, right? But don't forget to analyze the customer need and the timing for any development. I mean, okay, .NET 5 is fantastic. I absolutely love it, right? We can run .NET 5 in any platform, but we need to understand that for Azure Functions, for instance, this is not ready. And you cannot what I mean, you cannot just understand, try to use it in production because you're going to have trouble, right? This is really a good advice that I would say to you. And then here, thank you and obrigado, right? I am really sorry, I cannot hear you. I don't know why I'm not hearing you.
Okay, okay, Gabriel, you need to select, one of
I
your
am
favorite.
really sorry.
Okay, okay. We okay.
But
What we can
thank
do?
you, right?
Thank you, thank you, Gabriel. It was pleasant to have you in, and let's get in for our next speaker. Is Abhishek. So Abhishek is going to discuss about building broker solutions using .NET Core and Kafka. Hello, Abhishek.
Hey, hi Ashirwad.
Hi, Abhishek. How are you doing? Hope you're doing well.
I am doing good. How are you today?
I'm doing good too. Thank you.
Cool.
Okay, so let's get started with the session. All the best. Thank you.
Thank you. Hey, hi all. Let me share my screen. Just give me a moment. Ashirwad, my screen is visible now in the stream.
Yes, Abhishek, it's visible. We can start.
Okay, cool. So today I bring you an exciting topic like how to build brokered messaging solutions using .NET Core. To be very frank, possibilities are many. I bring you Kafka today, but you can do it with Kafka. You can do it with the RabbitMQ. You can also build like brokered messaging using our own Azure service bus and all those things. Like the possibilities are many. But in today's session, we will see Kafka because Kafka is quite famous. It is there for years, and I have seen a lot of enterprises using Kafka. So, like, I thought I will bring this session to you, and you will like it. Okay. And now coming to me, let me give a quick introduction of myself. I work as an intelligent cloud and automation architect. I'm a published author. I'm a Microsoft certified trainer. I have a deep experience in building intelligent Azure and .NET based applications. I have been building or working in .NET and Azure. .NET for specifically 15 plus years and Azure also like for more than 5 years. I have published a book on mastering Azure serverless computing with BPB publications. And I have a couple of certifications to make credit like TOGAF certified, Microsoft solution associate in machine learning, developer associate, architect level certifications, and many more. So that was a quick introduction on me. Without spending much time on me, let me get into the subject. Okay. So what are we expecting today? So like it won't be fair enough to directly jump into the .NET Core and show you the integration because I know like Kafka would be new to most of us. So I know like it's a very popular messaging solution or a streaming platform that we have today. I mean, it's a brokered like a brokered messaging system we have today. But I'll start with the introduction to Kafka. I will give an introduction to Kafka and then I will get into how to set up Kafka locally. So we need to have the Kafka cluster running locally. So I will set that up and show it to you so that you can understand like what exactly it is and how easy it is to set it up and get going. Then we will focus on our main area like how to stream and consume message to Kafka using .NET Core. And finally, we would wrap up where we will have a quick discussion on the questions that we have. Pretty much to sum up, like it would be a fairly quick and easy area, like not a complex one, but get into it. Okay, cool. So what is Kafka? So when I opened the session, I already told you like it's a brokered messaging solution. But again, we also have other brokered messaging solutions like RabbitMQ. We have Azure Service Bus. Like so many solutions are there. But what is unique about Kafka and why it is so famous? The answer is like it supports streaming. So it's a streaming platform. When I say streaming platform means it streams. It is able to like do a brokered messaging for like for streams of messages, and at the same time it is highly scalable and robust. And this is one of the most important thing in any architecture we do, right? So whenever we get into any client solutions, or we get into any kind of client scenario, or we talk to our customers, so what is the first thing we hear from them? Like they want their solution to be scalable and robust. When I say robust, it should be fault tolerant inherently. So with Kafka, we can easily get it done because it supports all the high availability features and faster accessibility features. We can have a cluster of Kafka running. So in the cluster, we can have multiple Kafka brokers in that. In a short time, I'll come back to what brokers are and all those things. So when one of the broker goes down, then another broker is there to serve your message. We can have partitions. We can distribute our messages in the partitions, and so many things we can do, by which we can actually address like scalability and robustness in our application. So then, one of the unique features of Kafka is like we can build in real-time data streaming architectures. So when I say real-time data streaming architectures, that means like I can bring in all my modern architecture or all my modern kind of applications like Internet of Things, any data solutions which really needs real-time data streaming. So like where I can ingest tons of that data in real time. So when I talk about Internet of Things, so we know like we bring in so many data at a single point of time, and we keep on bombarding our servers with so many data from different devices sitting across the world, or like sitting across so many locations. So we bring in so many real-time data, and we keep on pushing it to our system. So how to handle such kind of scenarios? To handle this, like Kafka is a best fit. So, and it's also like tried and tested across many enterprises. So like it supports real-time data streaming. So whenever you are thinking of building any kind of a Internet of Things application, or like some kind of a chatting applications, or any kind of that kind of applications, or even like nowadays Kafka is used a lot while building microservices architectures, where one of the service can keep on ingesting data, and another application on a real-time basis can keep on pulling the data and pulling the stream and reading it. So that kind of applications we can build in. I'll touch upon the microservices a bit, not in in a detailed manner when I'll be discussing the Kafka architecture. So we can bring in all these real-time data streaming and all these features like using this Kafka platform. I've already told it can really handle high volume of data efficiently. That means like there will be so many devices across the world in case of IoT, and they can put in a lot of data and volume of data. And my Kafka clusters, they're actually very much competent enough to handle that big amount of data. And the best part is that it is very easy to implement when we talk about our .NET environments. So and what is the best part of Kafka is like we can easily integrate it with the .NET Core. And thanks that we're to Microsoft, like when we got into the .NET Core paradigm, so we really become cross-platform. And when we became cross-platform, we started leveraging all these Linux-based tools, because Kafka and all these things, like they're more famous with the Linux architects and the Linux kind of architectures and applications. So since .NET Core is cross-platform, since it's really cross-platform, so it would be great enough to actually start leveraging this Kafka and all these kind of applications. I mean to say like messaging platforms and all. and also like other areas like Zookeeper and everything, like we were able to use it since we got into the .NET Core era. So using it's very easy to implement Kafka with .NET Core, like in like any other technologies or like Java, Python, anywhere we use a lot of Kafka, but nowadays with .NET Core also we can use Kafka. Okay. Now, I've already spoken about it. Like we have an excellent support for .NET Core and C# and .NET 5 also. Like think I'm seeing pretty much a lot of traction around there for Kafka, and very soon we'll be getting all the like NuGet packages for Kafka, and we can start using it. And it is truly a polyglot service. So why I wanted to specifically mention this polyglot thing is because nowadays, whenever we are designing any kind of applications, these applications are truly distributed, right? So it's not necessarily that a single team will build the entire application. What we do nowadays, so we build our application architecture in a way that our applications are splitted across multiple teams, and multiple teams will be sitting across the globe, and they have their own development language of their choice to build. Like maybe like one of the component or one of the module is built in Java, and another module is being built in .NET Core. The core processing engine is being in .NET Core. We have a Python component. So my modern applications, the modern application designs can bring in so many flavors to it, and they can be really truly distributed and truly disintegrated, and highly and highly very loosely coupled. Like they would be very loosely coupled, and they would have a global spread. So in that case, we can use Kafka to enable communication between all these components, or else it's a difficult affair, right? So imagine like we have a big application, and in that application or in that enterprise grade application, we have applications like components built with so many different kind of languages, and we want all these components to communicate. And I know there are ways to do it, but using Kafka, it's very easy. It's just like with messagings. So one of the component built with Java, it can actually send a message to the Kafka platform, and another component that is built in .NET Core can pull in that message and process it. So this kind of environment it supports, like, or this kind of enhancements or like facilities it supports. So it is truly polyglot. So it supports so many languages, and it and being a polyglot in nature, so we can build microservices using this, where like all my services can actually be built like in any languages of the choice, because all the modern microservices we are building, so like they need not stick to a single language. Like I need not build my entire microservices based application using .NET Core. I can build my microservices, a part of the services, or a few of the services will be in Java, few in Python, and few in .NET Core, and I can make them communicate with each other using Kafka. And the next best part of it is that we have already discussed is this, it is a best fit for monitoring reactive based applications. When I say reactive, so what I mean is like we can really build a reactive microservices. So it's a new kind of microservices patterns that we see nowadays, right? So where like my services can react to some kind of messages or some data. So we can have a CQRS like pattern implemented, and using the CQRS pattern, like we can push messages to the Kafka, and another receiving service can actually react to the messages. It can keep polling the messages and react to it. So those kind of applications I can easily build using Kafka. And let me move to next. Okay, and this is how my Kafka world looks like. Like it's pretty much of a architecture kind of thing, how Kafka works. So you can assume this producer is a .NET Core application, and a consumer can be say a Java application, or let's do it other way wise. Like producer can be a Java application and consumer is a .NET Core application, or like both of them can be like .NET Core application. Like the producer can actually stream messages, and the messages would be getting into a topic. So internally, like it's a Kafka broker. So that is where actually we directly communicate to the brokers. So inside the brokers, we have multiple topics. So what I mean by topic is like they're like logical containers of our messages. So like we can have we can have multiple topics in a Kafka broker. So maybe let me give you an example. You'll get to know like what I'm trying to say. For example, I have a order processing system, like a e-commerce microservices application I'm building. So one is like adding items to the to my cart. So that can be like one of the topic, that will take care of all the messages that is intended for adding items to the cart. I can another topic that is for like making the payments. For the payments, I can have another set of messages getting in. So those kind of messages can get into topic 2. So based on my requirement, like whether the customer is planning to check out some items from the cart or add some items to the cart, I can use the relevant topic. Or if he's making some payment, he can use the second topic. So that way, actually, I can leverage my producer and keep on ingesting messages into the necessary topics. And each of the topics will have multiple partitions. So we know, right, why we need partitions. Partitions helps us in first is we can make sure that we can access the messages fast. We can stream our messages into multiple partitions, so that we can do a kind of an indexing, and we can keep on getting the messages pretty fast. Instead of searching from 1,000 messages in a single place, I can divide my messages into multiple partitions, 10 partitions. Then instead of searching to 1,000, I would get a benefit of searching to just 10 messages. Okay, so that kind of benefit I will get. So that is how it is. So in a nutshell, like any broker, it consists of topics, and inside topics we have multiple partitions. And whenever any producer sends in a message or ingests a message to the Kafka broker, the message gets in sequentially. Suppose the message, it's just like a queue. So the producer has ingested the message 1 first, then the message 2, then the message 3, and then the message 4, in this partition. And when this consumer will consume this message, so what it will get is, it will be able to access the message that got into the queue first, like message 1. Then it will access the second message that is there in the queue, then the third, and finally the fourth. So this would be the order. The producer will keep on pushing the messages in the queue, and the consumer will get those messages based on the first in first out or our queue principles. Okay, so it follows that principle, the way we deal with the queues. And the consumers can pick up the necessary messages and process it. Now let me come to the .NET Core world. Now you will ask me how am I going to build a reactive microservices using this producer consumer scenario? So how I can achieve that? So the answer is we can bring in the CQRS pattern, and with the CQRS pattern, the producer can push in the messages, and the consumer, what it can do is it can use some, we have so many different mechanisms of writing a background services, right, or background processes. One of them is using the iHosted service. So using the iHosted service, I can keep on popping out the messages. I can keep a watch on the messages. So as soon as a producer drops a message in that, using the iHosted service, I can have a background message, a background thread running, or a background application running that will keep on querying this or pulling this queue, and whenever it finds a message, it will pop it out. So that is how I can build it. Okay. So that was pretty much of an introduction to Kafka. So what we have in Kafka, what is there in Kafka, and how actually the Kafka architecture looks like. Let me get into how to set up Kafka. Okay. So it's very simple. So I know if you have set up Kubernetes locally anytime, so I know it's so much of a mess, right? So we do so many things, but setting up a Kafka cluster locally is very easy. Or if you think of any other non.NET or a non-Microsoft software, setting up on your locally, it's a pain, right? I admit that, because I use Microsoft products, because Microsoft products have very good documentations. And when I set Microsoft products or I install Microsoft products, it's very easy. It's not that complicated. Whether you install SQL or anything, it's very easy. But when you go for any non-Microsoft products, it's really tough, and it's actually it takes a lot, right? So, but when we talk about this guy Kafka, it's very easy to set it up locally. you can set up a cluster locally in hours. Now, we can set up a cluster, but there are also easier way of using the Kafka. So if you are not planning to set up a Kafka locally in your production environment, you can use the Confluent Cloud. Confluent has adopted Kafka, and Kafka is anyways, it's an open source. There are different organizations who are working on this, and Confluent is one of them. So Confluent has provides Kafka platform as a cloud offering, and we all can actually we can create a Kafka cluster in Confluent Cloud, and we can use it. And the third best way that we'll see today here is the Confluent Docker. This is something you can actually set up your local environment in minutes. You just need to go to the Kafka documentation. I will take you there when I'll start with the demo. What I will do is I'll take you to the Kafka documentation, and then from the documentation there are steps. I will show you what are the steps, and I've already performed those steps, but few of the steps I have not performed intentionally, so that I want to let you see how it works. So what happens is using the Kafka Docker, they have created a Docker compose file already, and they have already kept it. So we just need to make a copy of it, we need to clone it from that Git repository, and then we can actually run it. And it's a Docker compose file where they have set up the Kafka containers, as well as we also need other components like Zookeeper, and also the control center. So many things are there, so which the Kafka needs. For example, Zookeeper to manage its environments, environmental variables and all. The control center that will actually help in getting into the Kafka cluster and working on it. So all these things are already set up in that compose file. We just need to build that compose file and run it, so that my Docker containers will up and running locally, and we can access it. So we'll see that in action in some time. So I'll go to the demo, but before that, let me also show you how to. Okay, let me first do this, then I will tell you how to consume this Kafka platform using .NET Core. Okay, let me open the terminal, and meanwhile, before that, this is the documentation for Confluent for Kafka. So maybe you can easily find it. You can just search it with just 3 keywords, like quick start for Kafka on Confluent Docker, and you'll get it. So in this documentation, these are the prerequisites. We need to have the Docker version installed, up and running. We should have the Docker Compose installed. Then these are the memory requirements that you can do. You can go to the preferences of your Docker, to your Docker settings, local Docker settings, and you can get it done. I'm not getting into all these things. I know you all are expert in this, and you can get it done. We need to have Git installed, definitely internet connectivity and all these things. The first step is to download this package, or rather this Docker compose file from the Confluent GitHub. So that this is a step. Once that is done, then you are navigating here, then you are running this Docker compose up command that would actually build your containers, and it will run your containers in a detached mode. That means it won't be a blocking run. So they will these containers will run in the background. And then what you can do is you can access the control center, where you will be able to see your Kafka cluster using this command URL. So normally it exposes on 9021. Okay, so many things I spoke. Let me just show you what I told about. If you're not getting it, don't worry. Maybe when you do it on your own, you'll be able to see, or when you see me performing this action, so you will get a clear picture of what it is saying. So I've already performed the first step. I've already cloned the repository, and let me now get into this, and I have this repository locally. So let me get into the terminal. Maybe your command prompt. It's in my Mac, we have the terminal. I don't have a command prompt here. It is same as your command prompt. So let me just increase the font a bit. Let me get into my directory. Okay, so I got into this directory as it has mentioned in this documentation. So I need to get into the CP all-in-one, and now I need to run this. But let me show you like what we are doing here. So if I do a inspect here, like what all things are here, I can see there is a Docker compose file, and we are actually building this Docker compose file. So let me quickly show you like what is in there. So cat Docker compose dot YAML. Did I write something wrong? Okay, so this is the entire compose file. So where actually you have you are installing a zookeeper or Kafka broker, and so many things you are installing here actually. So maybe you can inspect it. We are installing a control center. So like I need to have a control center running on my system. So all these containers, and also to test our system or to like ingest messages and all, I'm running a KeySQL DB server. So many things we are running it. So don't worry about it. So let's ignore them and go to the next step. Let me do a clear. So now what I will do is I will run this command. Docker compose upd. Okay. Now the next step is what I'm going to do is let me investigate if all my containers are up and running. So let me use this command docker compose ps. So I can see them as up. Let me just run it again. Okay, but since some services have exited, I need to run this command again. Docker compose upd. Okay, cool. It takes some time for the control center to be up. So like let me access it and check if it is already up. 9021. So it's still getting up. So let us give some time to it, and meanwhile I'll show you from the .NET end what we need to do. Let's see. So it's a pain actually, like at times like all the services don't start at a time. So while it's coming, the control center is coming up, let me show you what we need to do from the .NET end. Okay, so now what we have achieved is we are able to run the Docker environment locally on my laptop. Okay, now we will the Kafka environment, the Docker Kafka environment locally in our laptop. Now what I'll do, I will now interact with the Kafka. Okay, so how we can do it? It's again like very simple. Confluent has released Kafka NuGet packages. We just need to consume the NuGet packages, call the Kafka method, and we are done. Then we can easily interact with Kafka on Confluent Docker. So let me show that to you, what I have written. But meanwhile, let me just check whether my control center is up or not. Okay, it's coming up. Maybe it will take some more time. By the time I'll just show you. Oh, it came up. Okay, let's see that. So this is here, like it is the entire Kafka platform. Now it's, or the Kafka cluster is now like running locally. Okay, so as Docker containers on my laptop. So now I told you like it's a cluster, and it has brokers. Inside brokers, we have topics. Inside topics, we have partitions. So all these things we can see. So now if I go to the topics, so now using .NET Core program, what I'm going to do is I'm going to create a topic and ingest some messages into this topic. you will see a topic here, maybe topic-demo. So that will get created once my code has executed properly. But before that, let me walk you through the code. Okay. So this is for this, like, to start with, you need to reference these libraries, this confluent.kafka. Be a bit careful about the version. This version is exactly aligned with .NET Core 3.1. For .NET 5 also, like, soon we'll be getting the binaries, and then actually you can include that particular version as NuGet package for confluent.kafka and get going. Okay. So this is important step. As a first step, you need to refer the package confluent.kafka. Once you have referred it, now go to the program.cs, and here, like, you can see I have two methods, produce and consume. So what this produce will do is it will ingest the messages to Kafka. And when we installed Kafka, this is the endpoint of Kafka, localhost 9092. So the endpoint is running here, and we will be interacting with this endpoint, and we will be pushing our messages. For this, I'm using this class from that package, like producer builder, and then I am actually pushing using this produce async method. So this produce async method, what it will do is it will take in the topic, here I call the topic as a demo topic. I'm passing it here. So when I run this, what it will do is, so it will pass on the message to the topic, like demo topic, and the message. And what is the message? It's the string value, like I'm going into loops. So I'll be ingesting 100 messages starting from 0 to 99. So I is less than 100. And the message is something like hello 1, hello 2, hello 3, like that. I'm appending an I and I'm pushing it here. Okay. So now let's build this and see what it does. This producer. So I have built it. Now let me run it. Okay. So you can see it pushed few of the messages, like 100 messages to this demo topic. So let me go back to my Confluent UI and let's see. Here we have our demo topic. Let us get into the demo topic and see what it has. I'm not getting into the other things here because I don't want to do a Kafka session right now. We are interested in how to interact from .NET Core. Let me get into the messages part. And just to tell you, when we are using the Docker environment or running the Docker environment locally, so it is just for our developmental purposes or evaluation purposes. It's not a production scenario. So we just get a single partition and a single broker with us. Okay. So if I have a single partition configured here. So all the messages are going into the single partition only. So I can go to an offset maybe say offset 10. So by default it would be partition 0. So I can see all these all the messages post offset 10 streams out here. That means I have so many messages which I've actually got in here. Okay. Now what next? So I have a topic here and I have few messages. Now as a consumer, I need to consume these messages now. Okay. So I know what I need to do. I need to create a consumer here and I need to start consuming the messages from this. So to do that, we have another method here I've written that is consume. So let's see what it is. Let me get into the message and show you what it consume does. So again, it points to that this is your consumer name, demo consumer. Okay, we call it as a group ID in the package. So we are using this consume config. This comes from the NuGet package we referred for Kafka, and this is the endpoint localhost 9092. Okay, don't worry about this offset. So there are smallest, earliest, so many options are available. Don't worry as of now. So then what we are doing is we are subscribing to our consumer. See, I'm building a consumer here and I'm subscribing to that topic. So which topic? the topic where we have ingested the messages. Like if you see here, like demo topic. Okay, so like we have ingested our messages to demo topic. Now we are going to like subscribe to this topic and we need to read. So I'm getting into a continuous loop, but in real production scenarios, in microservices or in your IoT applications or wherever you are building this, you are not going to do this. So you need to use I-hosted service and build a background worker using I-hosted service and use this. But I wanted to keep the session very simple so that you get the gist of it, what is happening, and so that you can go back, do some R&D and find out how you are going to implement the things, and then like you can go to like you do the things with I-hosted service and get going. So just for demo purpose, I'm just using a while loop. Okay, but in real time you should be using I-hosted service, and you can see here I'm consuming the messages. Okay, and I'm printing it here also, like message retrieved from topic 0 is 1. I mean to say the name of the topic and the message. Okay, now let me run this. So let me clear the screen. Let me do a .NET build. Now let me do a .NET run. What it will do is, when I do the .NET run, it will start like consuming the messages from this topic, and it will do this console. It will pull those messages and do a console.write line. Okay, let me run this. Okay, so in a flash, it got all the messages. Okay, so one thing I would like to highlight here, see how this consumer will read is, so it will start reading from the 0th index. Let me just go back to the deck I had. So when I ingested the messages, it will start from reading from here, like, and it will complete and it would be at a single point of time, it will be pointing to a message, and it will keep on reiterating till here, like say message 4. And whenever you run the message, the program next time for the consumer, it won't start from message 1, but this message 1 to message 4 will be there in the partition in the topic, all intact. It doesn't go away. We set a retention, like you can retain it for a week, and so it will be lying there for topic for another consumer to consume. But the current consumer will be on the last read message, so that when the producer again sends some kind of messages or another set of messages, this consumer can again start reading from where it has left, like from the next set of messages. It won't be repeating from the first message. So that is something you need to note. Okay, so let me just come back to the consumers, and I can see a demo consumer has been created, and it is reading from a topic. If I get into this demo consumer, I can see the partition, I mean to say the topic here, and the partition is 0 because it's a development environment, and it's a like a single partition here. Okay, so one more thing I would like to show you, the containers that are running here. Docker con. Okay, let me just do a clear. So these are the containers you can see, right? The KeySQL DB, then this is the control center that we were currently, that UI, we got that UI, right? So that Confluent UI with which we were interacting with the Kafka, this is this guy. And our Kafka is also running. So you can see, like, we also have a Zookeeper. I told you for managing the environments, we have a Zookeeper running. So all these things are running here. Okay. So that was the story about pushing the messages to Kafka and pulling it. Maybe a lighter topic than the rest of the topics we have today evening. And now I think we are good to wrap up. So I'm open to questions. So any queries you have?
Hi Abhishek, it was really an amazing session, and let's look into the question section.
Thank you.
Okay, we got a question from Mohit.
Okay.
Okay. Just a minute.
Yeah. Would you mind just read it to me? Like.
Okay, I can read it to you. Can we maintain sequencing somehow in case there are multiple consumers and one consumer goes down and gets back up gets back up after some time while other consumers are still up.
Yes, that is the beauty of this Kafka platform. If your consumer goes down, suppose like I have 100 messages in the queue, okay, then I am reading 10 to 20 maybe say like I'm at index 20 and my consumer goes down. So what will happen is whenever that another consumer will resume, but again you need to handle that in your code, so you can resume from that 20th index and go on. That is possible. And that is how it should be, right? We should not be losing message. Yep.
Right. There's another question from Abhilash. Is when should one use Kafka over Azure Service Bus?
Okay. Kafka is a event streaming platform. So you should consider, see, both of, you can use, to be very frank, you can use Azure Service Bus, you can use Kafka. Okay. So, but where you can use Kafka in a way is, so Kafka is more related to reactive programming. Okay, you can build a reactive you can actually react to the messages that gets into the stream. Okay, and where you are dealing with streams of messages. So Kafka is a better candidate to handle like tons and tons of messages which are actually getting streamed, and you need to read the messages as it is coming in the stream. That is one. And the second point is, whenever we are building any kind of application architectures where we have different kind of different technologies, different languages of applications. Like I have an application built in Java, another in Python, another in PHP. Like there are so many kind of applications that are running, and they all are ingesting messages to the Kafka, and they're communicating along with themselves. So then in that case, Kafka is a good fit because Kafka is there from in the non-Microsoft world from a long time, and in enterprise grade applications I've been seeing that using. But again, at the same time, I would like to call out the same thing. You can also achieve that with Azure Service Bus. But just remember, when you are as an architect, when you are talking to your customers, or you are negotiating with your customers on a solution, so you can put in both the Azure Service Bus and Kafka and give them an option. At times, customers who have been using or new to Microsoft technologies, they keep on saying that we want to use the technologies we are familiar with, like say Kafka, RabbitMQ, and all those things, and they will try to keep on pushing that. In that case, you can actually see that Kafka, you can sell your product using Kafka. Actually, that is a thing that I have seen in at least in the client discussions I've gotten. But again, just for the streaming, it's for streaming and huge amount of data, Kafka is a good platform.
Perfect. I think that answers Abhilash. So we have another question from Anshuman. So it's more over like how to distribute partitions to distributed microservices. Suppose we have 4 instances of a service and we want to distribute for parallelly processing. I think he means parallel processing.
We can do that, right? We can have a producer, and the producer, we can write a code which can push the messages into multiple partitions. Okay. For example, I can have in a topic, I have a topic for maybe process my order. So how I can process my order? One payment module will be there, one checkout module will be there. So many modules will be there. For each of the modules, you can push in the messages to one partitions. Okay, and so once you push the messages, then there will be consumers who can actually read from the appropriate partitions, pull in those messages and process it. That can be done. You can achieve parallel processing very easily with this. But unfortunately, I'm using the development instance. So in development instance, it gives me only a single partition, or else I would have shown you how to work with multiple partitions. Maybe what you can do is you can create a go to the Confluent Cloud, and on the Confluent Cloud, just create a user ID and password. You get an environment for I think 1 month. So underlying, it will create some Azure VMs and all. So it uses them for the infrastructure part. But again, for 1 month, it's free, and you can just try that. There actually will get multiple partitions, and you can play around actually with it.
Okay.
And whatever you can do with the RabbitMQ. Yep.
Yeah. Please continue, Abhishek. Sorry for interrupting.
I was saying that no issues. So whatever we have with the RabbitMQ and all those things, right? We can do it here actually.
Okay, so I think that answers all the questions. So Abhishek, which question did you find the most interesting out of three that you got?
Uh, I would say like Anshuman speak, like that was more of a real real time question that we get, like normally this distributed processing. So that's I hear from my clients, and it's actually more to do with the actual business.
Okay, so
I mean, all the
Anshuman
questions
will
were
be
relevant. I would like to call out all the questions were relevant, and all of them are actually real time, and we get those questions. But Anshuman's question, like I liked it because that's a question that I get from my customers, and also the first question and second question are also like all these are relevant, but Anshuman is takes a bit edge. Yep.
Okay, so Anshuman, can you drop your email in the comment section so that we can share the e-copy of Gabriel's book with you on software architecture with .NET 5? Thank you, Abhishek. It was a pleasure having you on board, and we look forward to have you in our future events. Thank you. Have a great day.
Thank you.
And with that, we'll go to our last session for the evening. That is by Sanjay. It's on clean architecture and using mediators and web APIs for CQRS pattern. So over to you, Sanjay. Thank you.
Yeah, thanks, Ashirwad. Hi, everyone. It's been a great day. We have plenty of good sessions from different people learning on the different Microsoft technologies. And so currently, I'm just going to give a session on clean architecture and using Mediator and web APIs for CQRS pattern. First of all, I would like to thanks the UTF and the Microsoft for giving me this opportunity to present this session. So I am quite excited because this is my first session as a speaker. I have been to many technical conferences as an attendee, and so I'm quite pretty much excited. And let's dive into our session. So coming to me, myself, Sanjay Mrinal Kumar, and I was having 3 years of experience in developing different solutions using Microsoft technologies. I have been working on different frameworks right from starting of my career from ASP.NET, ASP.NET MVC, and currently we are working on that ASP.NET Core 3.0. And just now HEC is the architecture of .NET 5 and C# 9, and I'm still learning all the new stuff released by Microsoft recently. So apart from coding, I also involved in the design of the solution and the delivery of the solution, the deployment of the solution, including the CI/CD pipelines, all those stuff. Apart from my coding, I was tech enthusiastic, and I read many blogs and I write articles and share it with the community. So I was also skilled in building cloud native applications in Azure. So I was pretty much interested in the cloud applications, and I was have a good experience in developing applications using Azure web services, functions, service buses, etc., etc. And over the past 3 years, I have been mostly into development of solutions for supply chain management business, and that's a huge business, and have a good knowledge expert to it. So this is all about me, and let's start with our session. So over the next 30 minutes, I will be sharing some knowledge to you, and the key takeaways of the session will be like we'll be learning what is the clean architecture and why this design pattern is most useful for developing our solutions, and how it's different from the other architectures, and what are the advantages of using clean architecture. And then we'll be learning about the CQRS pattern, and then we'll be going into that use of Mediator to build our web APIs. So all these are individually different, but all these combine together to form a good solution for the project. So let's start this. If you can see, there are 2 images, one on the left and one on the right. So if you can see this image, so this image is completely tightly coupled. All the different items in this image are tightly coupled. So let's suppose if I want to upgrade this green marker with a red marker. So it is a very difficult task. Like there are a lot of dependencies. This green marker is dependent on in this stapler, and this is dependent on this. So it is creating a quite complex solution, and it will be difficult for anyone to upgrade or modify the system. So if you can look into this image, it is very pretty much clear and simple, and we can see that everything is loosely coupled. So if you want to just remove this green marker and replace it with a red marker, it is pretty much simple, right? So this is how our clean architecture is looking different from the other design patterns of entire architecture. We might be in our real life scenarios, we'll be developing a project which will be having an entire architecture. We'll be having the domain project, we'll be having model project, we'll be having the web services, we'll be having the Azure related projects, we'll be having the infrastructure project, we'll be having application layer, we'll be having UI layer. So all these projects should be loosely coupled so that whenever we are going to develop an application later or modify or something, do upgradation or maintenance of the application should be much easier. In this way, it will be easier for the developers to develop, and it will be easier for the business to upgrade their business, and it will be pretty much easy in our agile environment because we get the modifications at instantly and they get changed very rapidly. So this is how our clean architecture looks on a blueprint. So the core of the application of the is the domain layer. So this domain layer consists mostly of the entities and the repositories and the DB context, all the stuff related to the database and the models, entities, everything will be there in this domain layer. And on the top of the domain layer, we have one more layer called as application layer. So this application layer mostly consists of the business logic, all those stuff, which will be only depending on the domain layer. If you can see this image, the application layer is only dependent on the domain layer, but not the vice versa. The domain will not be dependent on the application layer. So this way, if we make any changes in this domain object or the domain layer, it will not affect the other layers. So this way, all the layers are loosely coupled. On the top of the application layer, we have the different types of layers like presentation layer, web API, infrastructure layer like the gateways. So these web APIs or the presentation layer, you can call it as a UI. So again, they are loosely coupled. So what this application layer does is give the data after processing, or it just do some operations, the crude operations with the data, which we'll be getting from the presentation layer or the web API or infrastructure layer or the gateways. So this is on the high level how the clean architecture looks like. So now if we go into the uses of the clean architecture, we can see the points here. The business logic can be tested easily without having UI database or any external elements. So the point clearly says like in clean architecture, we'll be implementing the logic in our application layer. So this way we can write the unit test cases, everything separately for that application layer. We can write unit tests separately for the web APIs. We can write unit test cases for our domain object validations, etc., etc. So this way, all the dependency on the different layers is segregated, and we can test our layers individually. And this is independent of framework and database. When I say independent of framework, because we upgrade our framework quite rapidly, right? We have started from the ASP.NET framework, then we have got to .NET 4.5, 4.6 now, then .NET Core 2.0, .NET Core 3.1, now we are in .NET 5. Maybe over the next 10 years or something, we'll be upgrading to different types of framework. But still, our clean architecture will be same in the way, and it will not depend on anything on the framework side. In the same way, it also does not depend on the database. What are the database? It might be a SQL Server, it might be a MongoDB, it might be a Cosmos DB, anything. It will not be dependent on that database part. Any changes in UI will not affect the rest of the application. So if you are changing the UI application, right, it will not affect the below layers like application layer or domain object because they are completely loosely coupled. Implementation of any new features will be relatively easy. Most of the software development is now going on that agile environment. So we get the requirement in the morning, the requirement gets changed in the afternoon, and we'll be developing something different by the evening. So the requirements get changed very randomly and very quick. So what we need to do is like in the perspective of the developer, we need to implement the new feature in a quick amount of time. So we should make our solution architecture in a way such that it will be easy for the developers to develop the different types of features. And debugging and finding the issues becomes easier for developer. So for any developer, it is very important to find the issues and debug the issues when we occur, right? So by using this architecture, it will be easy. Like if you have some bugs in your code, your test case get failed. Let's suppose I'm having an issue in the application layer. So my application layer unit test case get failed. If I'm having some issue in web API, my web API unit test case failed. This way it will be easy for the developer to understand where the code will be breaking. Maintenance of the code is effective and it is better solution for agile environment. We can develop the solution in any ways, but the main thing comes in how we are maintaining our code. It should be like when you come after 1 year also, you should be able to understand the code, because most of the developers, we do coding, and after if you leave that project and go for another and again come back after 1 year, you will be clueless of what it was written and which architecture it was written. So it will be easier for the developer's point of view to understand. And one more important thing is like whenever a new developer comes into the team, right, it will be difficult for him to understand how the architecture looks like, how the code flows, how the application flow looks like. So by this clean architecture, it is very much pretty simple and it is segregated. So it will be very much easier for a new developer to understand this code. So this is all about this clean architecture. I have some practical demonstration at the end, but let me go through all the CQRS pattern and everything. Then we can discuss on the practical implementation. But before that, if you have any questions, you can post it in the YouTube chat. So CQRS pattern, before going to CQRS pattern, by using entity framework, what we do is like we do the CRUD operations on the model itself. So a single model will be responsible for the create, read, update, or delete. So this way, what it happens is like all the querying is happening on the same model. Because of this, let's suppose while I want to retrieve the data of a model, I require only 4 properties. But while I want to update or create a model, I require more than 4 properties. So this way, my contradiction is different in my read query and the write query. So this by in the traditional approach, our model gets pretty much busy in doing all these operations. So how this CQRS pattern approach helps? In CQRS pattern, we have like commands and queries, which will help us in segregating the responsibility. So each command or a query will have only single responsibility. So this way, what it happens is like we may have a different model for getting the query. We may have a different model for creating a query. So all the queries are completely segregated. So the maintenance of the code will be again pretty much easier. And also there will be no locking of the models, and there can be like we can use the asynchronous task operators for this model to perform the operations. So what does CQRS? CQRS generally stands for Command Query Responsibility Segregation. The name itself, it says like we are segregating the commands and the queries. So what do you mean by commands? Commands are nothing but in the CRUD operations, we have like create, read, update, and delete, right? So all the operations which are related to create, update, or delete comes under commands. And what all the operations which are related to read comes under queries. So whenever you want to create an object, then you can use a command. Whenever you want to read an object, you can use the queries. This is what CQRS stands for. Why CQRS? It is mostly of the independent scaling. As I have mentioned above, like we will be segregating the different write operations into a different model, read operation into a different model, update operation in a different model. So in this way, everything will be independent of each another. All the write operations won't depend on the read won't be depending on the write. They are completely segregated. And this, the main point is like security. If you let's suppose if a model has 10 properties for creation, there are some data like created date, created by, updated date, updated by. There are some common properties for each and every model, right? But I don't require these models to be exposed while the application is using to query that data. So this way, there are some properties which needs to be hidden, not exposed to the data. So in this way, the security of the data can be achieved. And this is a separation of concerns. As I said, like all the commands and the queries will be completely segregated. This way, each command will have the single responsibility. Simpler queries. By using this CQRS pattern, we can achieve the concept of not having the like joins and everything. Only thing is like you need to design a database properly. If you have your database properly, you can write a simpler queries. So now let's discuss about the Mediator. Before going into that slide, Mediator is a name. It means like you are acting as a bridge between two or different objects. Okay, you have an object one, you have an object two. So what this mediator does is like mediator one gets the communication from the object one. The object one says, mediator, please do this kind of operation. So what that mediator does is like it will find the suitable operation which needs to be done, and it will communicate with the object two. So in this way, the object one will not directly depend on the object two. It only just sends the communication to mediator to do some operations, and the object two will do the operations which is initiated by the object one. In the same way, once the object two has completed its operation, it will produce the response, and it will intimate the mediator to send the response to object one. This way, all the dependencies on the objects will be reduced. If you have one or two, if you have a simple application, then in that case, you might not feel the use of a mediator in a broader picture. But if you are having a huge application, there are many classes, many methods. In that case, what happens like our application, each object will be referenced by more than 20 or 30 objects. So because of this, our application gets tightly coupled. If you are changing any object later on part of the development, the other objects also gets affected. So in order to avoid this, this is Mediator is a NuGet package which helps in communicating between the two objects. So the advantages of using Mediator are like less coupling. So as I mentioned, like there will be many objects, but no object will depend on the other. It will be completely independent of each other. Only the mediator takes care of communication with the object. Maybe you can just take an example of John F. Kennedy Airport in New York. It has a huge air traffic, so it will be difficult for to control the traffic, right? One of the pilot of the one airplane cannot contact the other airplane. So what they do is like they send the communication to the traffic tower, and they will mediate with the other airplane, and in this way they control the traffic. So the same role the mediator plays here. It will not think about the dependency of the objects. It will just take the request from the object, and it will produce the response to the object. Easier reuse. By using this mediator, right, we'll be having that single responsibility object pattern. Because of this, anything object you want to create, you can create on but it will not depend on the other objects. So this way, it will help us in maintenance of our code. As I said, like single responsibility principle. In previous approaches, we'll be using like we'll be having one function. If I want to update that function, we'll be updating that function only. So, but in single responsibility principle, each command or query will be responsible for only one function. It will not create many other functions. This way, what is the main advantage is like if you want to upgrade a single functionality, we will just change the code in that particular action block only. It will not depend on the other things. Open or close principle. this is also same. This is open for creation and closed for modification. If you want to create a new something new implement or something new feature, you again create a new command or a new query, and that itself should do the job. You should not be doing that you should not be using the existing object and improving that. That will be against our clean architecture principles. So let me go into that practical demo of clean architecture and using Mediator and web APIs or CQRS. So if you can see this architecture, I have like the domain layer, and then I have that application layer, and then I have that external layer called as API, or it can be UI or something. So in my domain, I have my domain models created and the repositories and my interfaces which do the job, and I have the DB context, all the stuff I will be having in the domain layers, all the entity configuration, everything. If I come into this application layer, I'll be having the commands and queries, which I have mentioned in that CQRS pattern. And this is my API project, which will communicate with the application layer. This will have only reference to, if you can see the dependencies, it will have only reference, it will not have any dependencies. If you go to this dependence of the application layer, it will have only the reference to domain layer. So this way, our clean architecture, this is how the clean architecture will look like. So in the domains modules, I will be creating some domains. I have created a domain for the time purpose, a customer. I have created a constructor which will be instating these values. And I will have the domain DTO models or the view models in this domain layer. And I will have that repository where I will be doing these operations in set async or whatever the stuff I need to do. So this is all about the domain layer. And now we look into like how the CQRS pattern looks like. So as I mentioned, like there are two things in CQRS. One is command and other is the query. Let's get started with the query. So what this query do is like I will have some set of properties of the related to customer model, customer domain, which this will be when application will be requesting for the list of customers or a customer object. Okay, so I will be creating the properties which are required for showing the object, customer DTO object to the web API or the UI which was requesting. So what I will do is like I will have some properties and I will create this I request. This is the I request is an interface of the Mediator, which as a where we need to provide the response object. So here what I will do is like I will be presenting the response of list of customer details. If you can go into this, we can see this will accept the response as an output parameter. So once we get this customer query, what we will do is like we will do some operation related to this query handler in the customer query handler. So this customer query handler will do this thing like what we are doing is like I have initiated the customer repository dependency injection. Then I'm trying to get the list of customers and I'm assigning it to the customer query object to the request. Okay, so our customer query handler will have the will inherit that interface of iRequest handler, which will again have the request which we need to do and the response which we need to produce. So these are the two parameters which we need to pass it to our customer query handler, to the request handler. So in our case, the request handler, the input is get customer's query. The get customer's query is this list of properties which we need to do. And the response is list of customer DTO model. This is the list of customer DTO model. I have the model which will have the list of properties. So this is how our query handler looks like. Now if we go into our commands and command handlers, so we, while creating the customer, I just need the properties like customer name, country, and if he's a prime user or not. But if you can see this just customer queries, I have some IDs and the joining date. So these are the properties I don't require from the user perspective. These are the properties my code will be assigning the values. So in the customer create customer, so now you might have understand why this. If you can this. We can now understand why this independent scaling does what is optimized data schema. So I am having two different models for two different operations. This query is for read operation, and this is for the creation of the object. Right. So what I will do is like I will create a customer command. I will create the properties, and I will create a initiate a constructor which will assign the values, and then I'll inherit that I request object. So what will this do is like it will create a response object. So my response object is GUID, unique identifier. What this? So once I create the customer, it should return me that ID of the object. So I have given this as GUID. So now I go into this create customer command handler. So this I request the handler, what does it do is like it will check if it gets any command from the create customer command. So once it gets any command, it will this handler method should be able to handle that command. So let's suppose from the API I'm sending this command, then this request handler will be initiated, and then handler method will do the operation. So what we are doing is, let's suppose if you got the create customer command, this handle method will be invoked, and then I'm creating the model of customer domain, and I'm trying to save. So once it is saved, I'm returning the ID, which is a GUID, which I have mentioned as a response object. This request handler will have T request and the T response. So this is how our command handlers, commands and queries and query handlers looks like. This way, here we have achieved that clean architecture. Here we have learned about our CQRS pattern, and then we will be learning about this mediator here. So once my application layer is ready, I am now trying to access that application layer through web API. So what I have done is like I have created two API endpoints. One is get, one is post. So my controller simply does a single job. What it will do is like it will send the query or the command through mediator. If you can see, the mediator is sending the query. The mediator is sending this customer query. So our API will not depend on what that query does, what that query returns, etc., etc. It will just send the invoke an object. So how to set up this mediator NuGet? You need to go to your controllers.api project, go to manage.NuGet packages. Then you need to install this NuGet mediate, or you can install this and this one. And again, you also need this mediator.extension.microsoft.dependency injection. This is also required because you will be doing the dependency injection of the mediator in all your API controllers. So these two are the NuGet packages which you require for creating your web APIs by using Mediator. So once you have created those, once you have installed those NuGet packages, I will be setting up in my startup.cs. So if you can see, in my startup.cs, I have added a services.add mediator type of. This will do like whatever the type request handlers. It will It will load the services. I have written just for sample object. So any kind of request similar to type of get customer query handlers, this mediator should work. So once I have done that, my mediator, I will do the dependency injection of that mediator, and I will then call my mediator dot send. This send is an object of that mediator NuGet. So this will send the request to the get customer query. So once the customer query receives that object, it will request our command handler. This command handler will this query handler will get this request and it will do the operations, and again it will send the response through our through the mediator. Then it will return the object. This way we will be setting up our mediator in our web API project. So let me try to debug, run the API solution. Let me show. Yeah. So my Swagger is ready. So I have created two endpoints, right? One is for get customer and other is for post customer. So let me try first with the post object. So I am now trying to post this JSON object to my DB. Okay. So now if you can see, I have my command ready. So I have the command entry, customer name, and the prime user. So my mediator is invoked, and it will send this command. So let me go to my command handler and let me keep a default point here. Yeah. Yeah. So my handler got invoked now. So my handler got the command, these things. Now I am trying to create the domain object with the values. So here I'm creating the customer ID, then I'm creating the joining date. So now I'm trying to add the customer. So it have, once the customer is added, it has returned me that customer ID. So in this case, so my API controller has sent this object, and it will not wait for it what it is operation this is doing or something. It has just sent that command. Now my command handler has done this job. It has created that customer data, and now it will return the response. I have got the response, which is the ID. Yeah. Now if we can go into database and see, yeah, my data got added in the DB, right? So now let me try to access the data from this DB. Let me try to go to customer get object right now. Yeah. So in the get API, what I'm trying to do is like I want to get the list of customers. So what I will do is like I will call this get customer query, and this mediator will send me this command to my get customer query handler. So I have got the request. So these values will be initiated from by the handler method. So my request got initiated. So the handler has done the job. It has written the list of customers. Now I have list of customers. This, I will be returning this. Yeah. So I have got the list of customers. So I have created only one object. So I have only got the single object. So this way, my mediator will only just send the commands. It will not depend on that other object. So let's suppose if I want to create something I want to create the object of seller. So what I will do is like again I will create a new query for the seller. I will create a new command for the sellers. This way, what will happen is like coming forward, I want to just update something in my create customer business. So what I will do is like I'll just go to my customer handler and I'll just change the code here. This will not affect the other changes. It will only depend independent of other classes or objects. So that's brings up my end of my section. If you have any questions, you can ask me.
Thank you, Sanjay, for such an informative session on clean architectures and using Mediator for getting CQRS patterns. We do have a questions from Christy Jen. It's about, do you have a Git repository for this example? Have you? Yes, Sanjay.
No, Ashar, but currently I'm not having. I have not had this code in Git repository. Maybe by after this session, I can push to this my Git and I can share it with you. You can share it with the attendees.
Okay. Okay. That would be absolutely fine. Or else you can add it in the comment section in this video.
Yeah.
Okay.
Yeah, I will do that.
Perfect. So let's wait a while to see if we do get any questions for some time. If we don't, then we're good to go.
Yeah. And if you have any questions or something related to clean architecture, you can connect me at LinkedIn or this is my email address.
Perfect. Okay. Okay then, Sanjay. Thank you for such an informative session, and we're looking forward to have you on board for our future events.
Yeah. Thanks, Ashirwad. It has been an amazing day participating in this .NET conference. Thanks for organizing this.
Thank you.
Bye, everyone.
Okay. So, okay, guys. So this was the last session that we had. I hope you people have already given the quiz, and we already have some winners who are going to get the ebook from our sponsors. So right now, I'd like to add Suvendu, who is a fellow community member of UTF, to give the vote of thanks. Hi, Suvendu.
Yeah. Hi, Asirvad.
Hope you're doing well.
Yeah, I'm doing great. So thanks, Asirvad. It's my privilege, to have been asked to propose a vote of thanks. I, on behalf of the entire team behind this event, organizing this event, and our community partner Utkal Techies Forum, then all the attendees, and on my own behalf, uh, I want to extend my vote of thanks to all the speakers for sharing their valuable knowledge with us. And it was a very great it was a great learning day for all of us, for me at least. Yeah. So with that, we also like to thank our sponsors, which is Pact and Microsoft and .NET Foundation. So we also want to thank all the audience for being here, for being with us this evening, and it's been a great pleasure to have you all here. So we hope that we will see you in our future events as well. Last but not the least, I would sincerely, like to thank Asirvad and Dev, Mirsa, for putting their heart out to manage this event and to manage the backstage throughout this event for so long time. So that's all. Thank you. Good night. See you again soon. And now it's over to Asirvad for the final words. Thank you.
Thank you, Suvindu, for your kind words. And we have all the winners for our ebooks. The people who are going to get the e-copies, they will. It is going to be shared over the chat section. Look into it to get that. And the results for the quiz will be out by January 12th. The winners will be getting notified about it in the mail. And I would like to invite Dave to join in the broadcast. Hey, Dave.
Hi, how's it going?
Hey, Dave.
Hi. Yeah, I'm a volunteer with the .NET Foundation, and I'm a software developer here in South Florida in the U.S. And we had a bunch of people, James Montenegro, Miroslav, and Abdul all jumped on to help with producing the stream. So thanks to them. And great conference, guys.
Thanks, Dave. Glad you like it, and thank you for the whole streaming support. It was really helpful. And big shout out to you and the whole .NET Foundation team, for helping us with all these things, organizing events, and helping us spread the word about .NET to our developer communities.
Yeah, and we're looking for volunteers. Ashwad, you're next.
Sure, Dave. Looking forward to the next event.
All right, great. All right, I'll end the broadcast now.
Sure. We can stay.
All right.